organizers and the speakers online. Thank you for coming online, and thank you so much. I think we can start the whole program. Let me initially share the whole program with all of you so that we know what we are doing. And then we can ask Dr. Wang to present our first guest of honor, and then Dr. Huang to present the other three guests of honor, and then we can start the whole session. Let me see, where is my slide? Okay. Can you all see my screen where I have the whole program online?
Yes. Yes. Yeah.
Let me see. Yeah. So thank you all for coming to the Taiwan-India Joint Seminar on Artificial Intelligence and Hydraulic Engineering. I think this is a first-time event which is being organized by IIT Ropar, CU, as well as
因为我的麦克风没声音，他们在用，所以可能等一下如果没有
Taiwan-India Joint Center on Artificial Intelligence. So currently we have four guests of honor, and Dr. Wang will be presenting our first guest of honor, and then Dr. Huang, the three other guests of honor, and then we'll start the whole program consisting of introductions to the Indo-Taiwan Joint Research Center on Artificial Intelligence and Machine Learning, and then we'll have two talks from the AI area, which is one talk from India and one talk from Taiwan. I think we'll go into the details of the talks later on. And then we have two talks from the industry, one by Tata and one by Tech Mahindra. And then we have two talks from hydraulic engineering. And then we can open all the discussions to all the participants. Of course, if you have any question, you can always post your question in the chat box, and then we can take the questions either during the session if we have time, or we can keep it for the end of the session. Yeah. So I think that is an overview of the whole program. Let me hand over the mic to Dr. Rohit. Would you like to first say something, or we can start the program?
Thank you, Professor Eric. Welcome all the delegates from India and Taiwan. And I take this opportunity on behalf of IIT Ropar to welcome all the guests of honors and dignitaries here. It's an honor for us to welcome virtually Dr. Shivaji Chandan, who is the Director of International Bilateral Cooperation Division of the DST, Government of India. Welcome, sir. Professor Sean Su, who is the Director General of MOST, or Ministry of Science and Technology at Taiwan. Welcome. Welcome from IIT Ropar. Professor S.K. Das, who is the Director, Mentor, and a great academician who is leading the institute, which is IIT Ropar. Welcome, sir. Honorable His Excellency, the Ambassador of Taiwan to India, His Excellency Bao Shun-ge. Welcome, sir. I also take this opportunity to welcome the Director of the Division of Science and Technology at MOST and the Taiwan Economic and Cultural Center, Dr. C.T. Wong. Welcome, sir. Welcome from IIT Ropar. And I also take this opportunity to welcome Professor S.M. Huang, who is the PI and the Director of the Indo-Taiwan Joint Research Center. Professor Huang, welcome to this event. Finally, I take this opportunity to welcome Professor Pao Wan, who is the Vice Director and the Coordinator from the Taiwan side for this center. It is an honor for me to welcome the speaker, and we would be really privileged to hear their experiences and learnings over the full day today. Professor Abhinav Dhal, who is a Professor of Computer Science and Engineering at IIT Ropar. Welcome, Professor Dhal. Professor W.T. Chu, who is a Professor of Computer Science and Information Engineering at NCKU, Taiwan. Welcome. Professor J.F. Lee, who is a Professor of Hydraulics at the University NCKU. Welcome. And Professor Deepak Kashyap, who is a Professor of Civil Engineering and also the Dean of Faculty Affairs at IIT Ropar. Welcome, sir. We also have two distinguished panelists amongst us who are representing the industry side. Mr. Karthikeyan Setumadhavan, who is the country head of TCS in Taiwan. Welcome, Karthikeyan. And also Mr. Ashwin Prasad, who is the business head of Tech Mahindra in Taiwan. Welcome, Ashwin. With this, I hand over for the next round of formalities to Professor Eric. We can request the honorable guest to say a few words. Professor Eric, it's all
let me hand over the session chairing to Dr. Wang. Dr. Wang, please.
Okay. Good morning, everybody. Yeah, very happy to join this wonderful seminar. Dear honorable guest and speaker of the Taiwan-Indian Joint Seminar on AI and hydraulic engineering. My name is Cheng Wang, and I am the director of Taiwan MOS, Taipei Economic and Cultural Center, TECC. Before today's seminar, I would like to first to thank Dr. Huang and Dr. Rofi, and finally is Dr. Chung for supporting this seminar. As for this schedule, we are so lucky to invite Dr. Shivaj. He is the director of the International Bilateral Cooperation Division, Department of the Science and Technology, India, to give the opening speech. So welcome and please, Dr. Shivaj. Thank you.
Good morning, all of you, all the eminent speakers in this forum. And thank you, Dr. Wang, for giving me this opportunity. So, Dr. Suhang, Director General, MOS Taiwan, Professor S.K. Das, Director, IIT Ropar, IIT Mandi, His Excellency Ambassador TECC, and Deputy Ambassador who is also present here, Dr. C.T. Wang, Director TECC, Dr. Sin Ming Hyong, Director Taiwan Research Center, and Professor Rohit Sharma, who is IIT Mandi, who is coordinating very efficiently and working for the last few days on this activity. And at the very outset, I would like to compliment TECC and IIT Ropar, IIT Mandi, sorry, for organizing this very important activity, this important seminar. And the theme chosen by the organizers is very contemporary and very important in this present context. There are several themes going on, but the artificial intelligence and the hydraulic mechanisms, which are very, very important. And this theme is very most relevant to both the countries at this present context. So I would like to briefly mention the Indo-Taiwan cooperations from the governmental side. And this is one of the latest cooperation going on, but this cooperation is very steady but very strong, going stronger and stronger. So far, over the last decade or so, we have been actually working very rigorously and very aggressively on several themes which are very relevant to both the countries. And last year, we had the joint committee. The entire mechanism of the cooperation is actually steered by the joint committee, which is headed by eminent scientists from India and the counterparts from Taiwan also. And in the last couple of meetings, they have been actually stressing so much on this artificial intelligence, medical device development. And because in the before last year, we had the 9th joint committee meeting, where Professor N. Balakrishnan from ISC Bangalore and a team of scientists from India visited, and it was a very exciting meeting. And the themes are actually chosen. It's very systematically things are happening in this cooperation. We have organized several joint workshops. The joint workshops are not simple workshops. The joint workshops are actually focused on so many themes. And in the last 2018, we had the joint workshop at IIT Madras on artificial intelligence. And then during these workshops, there are several constructive recommendations and constructing opinions are being emanated during the workshops, and these will be taken up further from both sides for the joint launching the joint calls and joint other mechanisms. So of late, the committee in 2019 again recommended several joint workshops, which is on cyber security themes and then medical device development. And the joint projects are actually, there were enormous response to the Indo-Taiwan joint calls, and we always receive more than 150, 200 proposals. But due to the limitations of the funding, limitations of other important things, we only limit the projects up to maximum 10. The quality is very highly maintained from both the sides. And in the last call, we have received more than 150 proposals, out of which we are actually recommending, the committee has recommended only 8 or 9. And then several things are happening. And then, of course, we have not announced the results now, but we'll be soon announcing the results. So with this, I request all the eminent panelists, the presence of our director, IIT Mandi, and the ambassador, deputy ambassador, this shows the significance and importance of this kind of workshop in the present day context. And I really request all the eminent speakers here to delve into the subject and also identify key areas on which both the countries should work for next couple of years from now. This is very important. It's not that we speak and then go on speaking and then speaking, and after this one-day workshop, we should not actually forget what has happened. So I request and urge all the speakers here to identify the key areas which are important for both the countries, and then these recommendations will be taken up further for in the form of joint projects or joint research collaborations and all. And also identify what are the gap areas in this cooperation. So this is very important. The only you people like experts like you only can identify the gap areas because artificial intelligence and the subject chosen, theme chosen here is very, to my understanding, this is very broad in nature. So therefore, within this broad area, what we need to set is what are the key gap areas in this broad subject. So this is very important. See, the broader area is very good for inviting more larger participation. But within the broad area, we need to identify what are the gap areas in this present day cooperation between the two countries. And this is all, it should be also come to both the countries and what are the weaknesses of both the countries, and so that a complementarity can be established. So if India is weak in certain aspect, or if Taiwan is weaker in other aspects, and India's positive things and the gap areas can be actually collaborated. So this is the real cooperation in this entire era of international cooperation. So without this complementarity, whatever efforts you are doing, it will not lead to the expected results. So therefore, once again, I compliment IIT Mandi and Director IIT Mandi for very actively coordinating this important activity, and all my Taiwanese colleagues. Also, I appreciate their deep sense of participation and coordination of this activity. Thanks a lot, and I'll be watching, and I'm here only, and we can further discuss on what are the important things that can emerge out of this very important joint workshop. Thank you very much.
Thank you, sir.
Thank you for the Dr. Shivaji. Yeah, for his, I think based on his the good support, I believe that we will have the good outcome.
It's always nice to have a contact with India, and for this research center, I made a lot of good friends in India, and we joined a lot of projects together. I became a very good friend. So even the COVID-19, we still have no distance between Taiwan and India. My name is Cheng. I'm the director for the Taiwan-India Joint AI Research Centers. And today we have the conference. I would like to thank all of you to help. And hopefully with this today's conference, we can make some of the conclusions and make forward for the Joint Research Center with all of others in India and in Taiwan professors and experts together. So in the beginning of the conference, I would like to invite some of my good friends to make an open speech. Firstly, I would like to invite our Director of Engineering Department for the most in Taiwan, Dr. Xu, for his few words for congratulating for this wonderful conference. Let's pass to Dr. Xu.
Thank you, Professor Huang. Good afternoon, everyone. I'm really glad to have the chance to, on behalf of MOST to attend this event. Director Shivaji, Director Wang, and Professor Chung, and Professor Das, and all other our distinguished guests from both academia and industry. And so today, this event is Taiwan-India joint seminar on artificial intelligence and hydraulic engineering. So I know we MOST had an excellent research center established in 2017 between our Deputy Minister Xu, Dr. Xu, went there to visit India. And I think this is the a very good beginning for the in-depth collaboration for this Center of Excellency. I know this center has been very active, so have a lot of activities like joint courses between both sides and research topics, a lot of research activities, and also have webinars and exchange students. I think this is really established a high standard for MOST to have foreign collaboration with other countries. So I'm really glad to have this. I think this of today's seminar. So it's quite interesting, actually. It's like artificial intelligence and hydraulic engineering. And both sides get together to know better from both sides and have some new ideas. To attend this event, and I know this year 2020 has been really difficult for most of the countries in the world because of the pandemic. But I believe through this research for different for this topic, and we have many talents in academia and industries work together. We can bring people a better world. Thank you very much, and wish all the best to all of you, and a very successful event today. Thank you.
Thank you. Thank you for Dr. Xu. Next, I would like to talk to my very lovely friend, Professor Das, because I've been the your university last year, and the last time you were just in the. Let us welcome Professor Das, the director of the IIT Ropar. Welcome.
Thank you very much from IIT Ropar. Probably it is important in all these kinds of discussions when two countries are involved, what is the importance of the two countries and their collaboration in the geopolitics, and hence I will keep that one, but it goes without saying that geoscientific is an outcome of geopolitics. And in that respect, I think India and China has got a bright future if they can really come together. India and Taiwan. Now the thing is that Taiwan is known as the capital. He knows that. Sometimes we call it is the foundry of the world. On the other hand, India is known as the capital of softwares of the world. Now, interesting enough, in today's world, the hardware and software are not really separated. With artificial intelligence coming, embedded systems coming, the importance of IoTs, integrating them with artificial intelligence, needs that whoever is the fabricator, whoever is developing hardware, also understands how to implement softwares in it. And the opposite is also true. A country cannot just rely on the software power, because softwares are getting embedded in hardware, and so they need to also understand hardware. And this is where I think Taiwan and India are very, very important to come together to learn from each other's strength. Now, as Dr. Shivaji has told, many cases we see that the center started working. Indo-Taiwan Center, it was sanctioned. I still remember that Dr. Yu-Shin Shu, the Deputy Minister of Science and Technology, visited Ropar campus, and that time His Highness the Ambassador in Delhi also came along with him, and we had a formal inauguration program in 2019, but the center started working even before that. Not only that, we had the Taiwanese professor coming here and offering short-term course. How many months? I think 3 months course, right? We had a 3 months course where the Taiwanese professor came here. We had courses online from both the sides. Now, last year, our Senate and the Taiwanese university, National Chung University, we have started a joint PhD program. So, what we are talking today, we are not just talking, we are talking with concrete outcomes already on the ground. We have got the center working, we have got the joint courses running, we have got the joint PhDs running. Our faculty members are traveling to Taiwan. Our students are traveling in a very large number to Taiwan for their summer internship. We said that our industrial internship, which is to be done by third-year students, they can do it abroad. Specifically for Taiwan, we relaxed it, and a large number of students in every year, some 30-40 students, they travel to Taiwan to take the summer internship. So we have already built that bridge. I'm sure Dr. Shivaji will look at these while deciding about the projects that two universities who are already working together. IIT Ropar is already working with Taiwanese counterparts. So we have already applied for the joint projects. I think DST will look at that favorably, because this is something you can depend on. The momentum has already built up. On the other hand, I was about to visit towards the beginning of this year Taiwan, but then the pandemic came. But I promise that whenever the pandemic goes down and there is a possibility to travel, my first travel abroad will be that of Taiwan, because I am committed to that. I would like to come, and I would like His Highness the Ambassador of Taiwan Cultural Center at Delhi to help us in connecting to industries like TSMC. We want to become a partner. You have got wonderful research parks, and we would like to get connected to that. We already talked to the, in our last meeting, we talked to the chairman of that research park. So what IIT Ropar wants to do is to create an ambience where free flow of students, faculty, joint projects, this happens between these two, and we have already started that, and on the ground we are creating the facilities for that. Today's seminar, if you look at the first sight, when you look, it looks completely two poles. One is water, one is artificial intelligence. What is the connectivity? First connectivity is this, that in the future, the big war has to be fought either on the information or on water ground. So water and information are going to be the two major points for future, even for maybe wars between countries. And hence, it's very important to be at the top of that. But at the same time, these are the two things we have seen, particularly being in Punjab, in India, which is an agricultural province. We see that water is the lifeline of millions of people who are, farmers and the businesses related to farming. And so, the water management, distribution, quality, testing, if you look at all aspects of water, it's just impossible to do it on a one-to-one basis. You need to have large network of sensors. You need to have those huge amount of data to be analyzed using machine learning and artificial intelligence. So water and artificial intelligence are also going to be connected. There is a tremendous need to connect them. I hope today's seminar will look towards that, and the already existing collaboration between us, the Taiwanese universities, and the Taiwanese government will enhance in this direction in improving the quality and the availability of water in both the countries, as well as to march forward to complement each other in our strengths of hardware and software engineering. I welcome all the guests, all the dignitaries, our honorable, the head of the center at Taiwan Center, Ambassador Baoshan Ger, and all other dignitaries to be enthusiastic by this seminar and look forward for a very successful collaboration between IIT Ropar and Taiwan. Thank you very much.
Thank you. Thank you for Professor Das have a wonderful speech and make a strong link between Taiwan and India, especially IIT Ropar and the National Zhongzheng University in Taiwan. We are just have a cyber bridge. Two side professors work together, two side students work together. So it is wonderful experience for me. Can supervise your student in India and talk by the internet. The next one, I would like to invite our Vice Ambassador in India. I'm sorry because our Ambassador in India have an important meeting now, so he cannot attend. And the Vice Ambassador, Mr. Jack Howe, will have the speech. And before his speech, I would like just find out, you know, the Taiwanese, we always like them called Jack. My name is Jack Huang. I'm the team of research. Our team of the international affair also called Dem Xu. So when we in the IT Ropar, you say why the National Zhongzheng University, the professor always like called Jack. But now we find another Jack that's in India. I believe he can make a really strong connect between Taiwan and India, both sides. And especially, I really like this today's talk because for my research, I'm in the AI for substantial development. One of the key issues for the United Nations SDG 6, that's also try to make clean water for the people to drink. So it's one of the subjects for all this conference. So I hope today we can have some really conclusions and make forward to make both sides can have the nice team together to make these waters become manageable and clean water. So now I would like to invite Jack Hao, our Vice Ambassador in India, New Delhi, give us some of your words. Welcome, Mr. Hao.
Thank you so much, Professor Huang. My friends of India, good morning to you, namaste. And to my friends in Taiwan, good afternoon to you. Dr. Chalman Shivaji, Director of International Cooperation, Department of Science Technologies, Dr. Hong Xu, Director General of Department of Engineering and Technologies, Ministry of Science Technologies, Professor Das, Director of IIT Ropar, Dr. Xu Ling Huang, Dr. Lohit Sharma from India's Taiwan Joint Research Center on AI and Machine Learning, distinguished guests, ladies and gentlemen. It is indeed a great honor for me to represent Ambassador Ge to take part in this important seminar. I would like to thank you all for devoting yourselves to the mutually beneficial cooperation between our two countries. In the past few months, the COVID-19 pandemic has severely impacted all countries around the world and our daily lives. And Taiwan has managed to keep confirmed cases under 750 without imposing a national lockdown. It is also encouraging that the pandemic does not stop our academic exchanges in the field of science technology. Since the establishment of the Indo-Taiwan Joint Research Center on AI and Machine Learning in IIT Ropar in July 2019, the AI Center has completed multiple joint programs, monthly webinars, and advanced research results. At the seminars today, the focus is not only on academic discussion. The AI Center has also invited experts of the Tata Group and Tech Mahindra to jointly explore technology transfer from laboratory to industry and to seek possible collaboration. The application of AI in hydraulic engineering has had a few successful examples. AI could help to make accurate rainfall predictions up to 6 hours ahead of time to improve the efficiency of water management and disaster prevention. When being utilized in precision agriculture, automatic control of AI-based irrigation system makes the water resources management efficient. I look forward to report outcomes on the seminar and hold our cooperation on science technology will continue to expand to meet the mutual interest and to further promote the economic development of our two countries in the years to come. And in the post-pandemic era, we welcome Indian friends to visit Taiwan, and TCC will be happy to facilitate the visit, including all the program arrangements. And of course, we welcome our friends in Taiwan to visit India again so that we can meet again to discuss possible cooperations. And to conclude, I wish this seminar great success and wish you all the best of health. Thank you.
Well, thank you. Thank you for all our distinguished guests give the opening speech. Now I will suggest the seminar will move to the next sections.
Okay, thank you, Dr. Huang, for introducing our guests of honor. Moving to the next session, we have introduction of the Joint Research Center, which is currently located on IIT Ropar as well as CCU. Dr. Rohit, would you like to go first?
Sure.
Dr. Rohit?
Yeah, sure, Professor Eric. Thank you. I'll give a brief presentation. So let me present my screen. And Professor Eric, just let me know if you can see my screen.
Yes, I can see your screen.
Thank you, and welcome once again from the Indian Institute of Technology at Ropar, National Chung University. We are a center which is a bilateral research center in the area of artificial intelligence and machine learning and applied AI and machine learning to a host of application areas. As we can see today, we are talking about hydraulics engineering. It's a joint center which has been granted to the Indian Institute of Technology at Ropar and the National Cheng University in Chai, Taiwan. Briefly about the two universities. CCU, as is popularly known, is a public university which was founded more than 30 years back with 5 distinct colleges in humanities, sciences, social sciences, engineering, and management. Later on, 2 more colleges were added up in the areas of law and education. As on date, CCU is offering around 29 programs, 44 master's programs, 29 PhD programs, and 17 in-service graduate programs, with a total student strength of more than 10,000, 12,000 to be precise, and nearly 1,000 faculty and staff members. It's a highly research-oriented university that is aiming to provide advanced skills in several interdisciplinary areas like humanities, social sciences, technology, law, management, to name a few. IIT Ropar is one of the newer IITs that was set up by the Ministry of Education in the year 2008. It is located about 250 kilometers north of our capital, New Delhi, almost in the lap of Himalayas. We invite all of you to our brand new campus, which is visible here, and we would be delighted to take you to the Himalayas on an excursion tour. We are an engineering and technology-centric research university, which has offering 7 undergraduate programs, 17 master's programs, and 11 doctoral programs, with more than 2,400 students and 350 faculty and staff members. We are focusing on socially relevant, high-quality research, which are so pertinent to this region, to our country, and globally also. With our specific thrust areas in the areas of water, food, agriculture, health, energy, to name a few. One of the USPs of our university is that we are a very young university with very young people. The mean age of faculty members here is something around 38, and therefore, once you collaborate with our faculty members, you will definitely see the zeal, energy, and enthusiasm in working with our counterparts here. A little bit about the center. The center is a bilateral research center in the area of applied machine learning and artificial intelligence. It was granted in the year November 2018 for the first phase of 3 years up to December 2021, jointly to the National Cheng University and IIT Ropar by the Ministry of Science and Technology of Taiwan. It was formally inaugurated in July 2019 by His Excellency the Ambassador of Taiwan to India and Deputy Minister of Science and Technology. The aim of the center is to provide, in AI, machine learning, promote student exchange, faculty exchange, provide industry incubation. We have partnered and several other Taiwanese companies who have presence both in India as well as can I request some of you to mute your mic if you don't mind? Thank you. This is the organizational structure with Professor Huang as the overall PI and the director of the center, Professor Eric, as we popularly call him, or Professor Pawan as the vice director, myself, and we have staff members as well. The major activities that have been done, Professor Das has very nicely summarized some of the major activities, but to list them down once again, this includes exchange programs for faculty, students, and internships both ways, workshops, and we have already conducted monthly workshops even in these times of the pandemic, webinars. Every month we have a webinar, which is either from a speaker in Taiwan or a speaker in India. As you can see, the Deputy Minister inaugurating the center in last to DST Gita and to other scientific bodies. And we have also started online certification courses for industry professionals with industry partners. Also we are planning to have FDPs and other academic activities as we move forward. We are also in touch with the government of Punjab under the Invest Punjab initiative, and we were expecting a team from Taiwan to visit us in February and meet the officials of Punjab government. But unfortunately, because of the pandemic, that visit got postponed. But we hope to see you very soon here on our campus. With this, I thank all of you and request Professor Eric to take back the remaining of the formalities. Professor Eric.
Thank you, Dr. Rohit, for the introduction to the whole center and whatever we have been doing for the past 2 years. Dr. Huang, Dean Huang, would you like to add something to that?
Oh, yes. Yes, we have a wonderful experience to work with the IT Ropar. National Zhongzheng University is one of the major research universities in Taiwan. And as the Rohit to say, we have 7 colleges in different disciplines. So the university is one of the like big families, and the students can work together. And we make a campus is we call the Indian student friendly campus, which students come to the campus. They have their student association. We call Indian student associations, and they are legal association in the universities, which they can join a lot of the university events, and they also got a vote. So it's some kind of the environment to make a student can really work out and really do research in these areas. And the National Zhongzheng University, we have we call the ORS, Overseas Research Student Scholarship, which we issue a 30 students. If they want to study PhD, they can apply this scholarship from the university to come to the Taiwan. It's one of the good salary and a good environment, and they will be free tuition and free accommodation in this campus. So we are using this chance also invite all of the students, if they want to study in Taiwan for the PhD programs. National Zhongzheng University is very welcome. So I really love these cooperations and work with India. So wish all of you have the best. Thank you.
Thank you, Dr. Huang, for complimenting on whatever we have been doing for the past 2 years in the center. Thank you all for all the opening remarks and the guests of honor to come on online and discuss with us. To keep to the schedule, let us move to the actual talks that we have been waiting for. Dr. Rohit, would you like to chair the first talk?
Thank you, Professor Pawan. And maybe I can start with the first technical session now. This technical session is on human-centered artificial intelligence. And this talk will be presented by Professor Abhinav Dhal. Professor Abhinav Dhal, may I read his brief introduction? He's an assistant professor at the Department of Computer Science and Engineering at IIT Ropar. He also is the co-director of the Human-Centered Artificial Intelligence Lab at Monash University. Dr. Dhal received the PhD degree in computer science from Australian National University and had postdoctoral experiences at the University of Canberra and the University of Waterloo. He has also pursued research at University of California, San Diego and Imperial College, London. Currently, he is an associate editor of the IEEE Transactions on Effective Computing. He is also a member of the IEEE and ACM and a dear friend of mine. Professor Dhal, welcome once again. And the stage is all yours. We can see your screen, so you can go ahead with it.
Thank you, Dr. Rohit. Respected dignitaries, Professor Das, respected Deputy Director Taiwan Embassy, Dr. Sivaji, and my dear colleagues from India and Taiwan. Namaste and ni hao. So I'm going to make my screen in the presentation mode. Can you please tell me if you can see it in full screen now?
Yes, we can.
Okay. So I'm going to talk about a really important direction in artificial intelligence, which we are calling now the human-centered AI. So as we all know that, in the past 20 years, artificial intelligence now is becoming omnipresent. We see it in devices around us, and we see that with the devices enabled with AI, our society is getting transformed. We have access to effective information. It's easy to present information. It's easier to make decisions. So what we see is that, these AI algorithms and AI systems, they are now getting really good at specific narrow tasks. For example, you can have a camera in a phone which can help you in clicking a photograph in a better view. It can focus better on the faces, and it can also, let's say, highlight the really important aspects of the image. Let's say food there, right? And then tell you that, okay, that's Abhinav and that's someone else in the photograph, right? So these are very specific tasks. Now, for AI to assist us human beings better, for effective usage of machines, and for more productivity and safety, we need artificial intelligence algorithms and systems which are human-oriented. Now, what does human-oriented or human-centered mean here? We mean that the AI system, it learns from and it learns with the users. So it is learning the pattern of the user and is trying to then assist the user in the most effective way. Further, it also tries to learn to detect the behavior of users. So for example, if a user is quite stressed, looks unwell, based on the visual information or the speech information, then the system can actually give some recommendations. Further, the human-oriented AI system is the one which will observe the environment around the user, so that it can assist not only in the safety, but also for having a more ambient and a healthy environment, which can promote the well-being of the users. Further, another direction in human-centered AI is algorithms, which are particularly focusing on the aspect of collaboration between humans and machines. For example, we have a robo interacting with a group of students in a class, or a robo interacting with people in old age homes, right? So how can the machine understand the emotional state of the user and then try to assist the user in a more effective manner? Further, the most important aspect, which now, since AI is becoming a major part of our lives, is that we want algorithms and systems which are ethical. Algorithms which do not bias against people of a specific color, of people of a specific ethnicity, and are giving equal importance to all the users. Further, for the AI systems which are to be used in critical environments, such as let's say, a system which is automatically analyzing CT scans of the lungs of patients and then categorizing chances of this particular patient having, COVID-19 or not. So these kind of systems need to have an explanation as well, which can tell the users how they reached onto a particular decision. Further, since we have so many devices around us, we have our smartphone, we have smart watches, we have our computers, our laptops, and even surveillance cameras. How can these human-centered AI algorithms preserve the identity and the personal private information of the users? And further, we need transparency. If an AI algorithm has made a decision which has gone wrong, who is responsible, right? These are the ethical sides of AI. Is it the programmer who has made the system, or is it the hardware developer on which hardware the AI system is running, right? So these are the different directions which are now being added to AI, and there are many teams around the world in big universities in industry which are focusing on the human-centered artificial intelligence aspect. So what I'm going to do is I will be taking some of these different facets of human-oriented AI, and I will be showing you some of the works which we are doing with our colleagues and students. So the first aspect which I mentioned was that human-centered AI is that AI would learn from and with the user, right? And some of you would have come across this term called deepfake. Now, deepfake is these videos and images which have been manipulated by the deep learning based algorithms. Here is an example. You see a video of me. Here is an image of a really popular Hollywood actor, Tom Hanks. And let's see what the system generates.
Hello, I'm Avinash. I'm going to present our work, Not Made for Each Other, Deepfake Detection.
So as you can see here that we can now do automatic facial mimicry, right? And this is really scary. We can actually have these AI systems which could be used to run social media campaigns and spread misinformation. And further, this kind of technology can also be used for trolling online, right? So how can we create these systems? How can we create these AI-centered systems which can detect and tell if a video has been manipulated or not? So along with our students here, what we are doing is we use the concepts which are already there in the well-studied field of human perception. Okay, so here it is. So we hypothesize that if any video has been manipulated, okay, then there would be a disharmony, disbelongingness between the audio and the video of that particular video. So one could observe loss of lip sync, some unnatural facial movements, unsynced lip movements, right? And this is based on the seminal work of Grimes and others from 1991. So Grimes, the psychologist at University of Texas, who was studying the behavior of users when they watch TV advertisements, right? So he noted that whenever there is a sync issue, whenever there is, let's say, audio is not synced with video, then the users would notice it, right? So this dissonance is noticed by the users, which tells that something is odd with that particular media. Now, how can we map this thing onto a AI-based system? Okay, so we make the system here as follows. So let's say this is a video and this is the corresponding audio. Now we analyze the face of the person. So there is a deep learning based algorithm. I will not go into technical details. However, I'm happy to share the paper for anyone later after the talk. So this analyzes the face, and then we have the corresponding audio. Okay, so for this video chunk, this is the audio chunk. For this segment 2 video chunk, we have the second audio chunk. We analyze the audio, and we kind of compute a score. Okay, so we compute a score which tells us that how much is the belongingness of the audio to the video. If the audio chunk does not belong to the video, that could mean that either of the two have been manipulated. And this is really easy to imagine. It's simply that, let's say you're watching a foreign language movie which is dubbed in English. So the audio doesn't really go with the lip movement, and we are always noticing that artifact, right? So when we train this kind of deep learning system, this is what we observe. So the video which I'm going to show you is a fake video. And here is a plot. X is the time, Y is the score which is generated by our AI system. High score means that the video is manipulated. It's a fake video. Okay, so this is a video which went really viral online of President
We're entering
Obama.
an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, kill them.
So if you notice here, right, so this is a manipulated video, okay? And what the AI system does, it compares the belongingness of audio and video, and then it tells us that, okay, the audio doesn't belong to the video. So there is some type of manipulation and hence the high score. And now let's run the same system on a real video.
We're entering an era.
So that's all again of President Obama here. So this is a real video which has not been manipulated.
Hi, everybody. And I thank you for that beautiful introduction. I could not be prouder of everything you've done in your time with the Obama family.
So if you notice, the belongingness of audio and video is intact. Okay, the audio signal belongs to the video signal, and the AI system gives a low score. So the low score means that there is no manipulation which has happened to the data. So essentially, in this, we are using the observations of the human perception to make an AI algorithm, a deep learning algorithm, learn how to detect if a video or audio is manipulated or not.
Hi, everybody.
Now, the second is we want the AI system to learn the behavior of the users. Okay, so in more precisely, that means we would like to understand that given a group of people, let's say given a group of students, what is the perceived overall emotion of the group? And once we know that, we can use it for things such as surveillance, for consumer behavior analysis, and for engagement detection. And for this, essentially, we have a deep learning-based pipeline which analyzes the faces of the members of a group and also looks at the whole image. So it looks at the whole image, the members of the group, and then it gives us a score which tells us that if the members of the group collectively are feeling, let's say, positive or they are feeling negative. Okay? And here is the video of the demo, which is doing frame level prediction. As you can clearly see, the sportsmen over here, the team has lost and they don't really feel, quite happy. So the score is mainly hovering towards negative, which is based on the facial expressions, the body language, and the head pose of the members of the team which are in this view. So we can actually train these algorithms now to detect the behavior of the users. Building onto this work is the third dimension, which is we want human-centered AI algorithms to observe the environment, right? And I think this is one of the best examples which is very relevant to the COVID times, right? We all, academics, are teaching online, and you would notice that the key element which is missing is that we cannot see the students. When we can't see the students, it's non-trivial to detect if the students are engaged or not, right? So we are actually creating these algorithms which can predict the engagement of a student towards educational material. For example, here the engagement is low, here the engagement is high, and then we are actually learning the systems on data which has been recorded from different environments. For example, this is in a Skype conversation, here the gentleman is outside, here this particular subject is inside a room, so that the AI system learns that people can be in different environments, in different situations, in different contexts, but it should still learn how the facial structure of a person looks like when they're not engaged or when they're highly engaged. And the same thing can be mapped onto a robo as well. Let's say we have a robo who's interacting with a group of students, okay? So when the robo is able to predict based on the head pose, that is where are the users looking? Okay, if you see me now, this is the head pose movement. Am I looking at the screen or am I looking to my right? So if the robo is able to understand the collective head pose of a group of students in front of it, it can then modify its tone similar to how we do it in classes, right? We can actually increase or decrease our pitch. And that can help in increasing the engagement of the students. Okay, so here is the video of one of the experiments.
She refused to sign the final adoption paper. relented a few months later when my parents promised that I would go to college. This was the start of my life.
So if you notice here, the robo is giving pauses in between. It is moving its arm so that based on how the users in the front are looking at the robo, it can then tell that if the engagement is low or high, and then take an action on top of it. So the fourth aspect is the ethical, explainable, privacy, and transparent. Okay, I'll just pick up one part of it because this is really broad. This in itself would be, in the coming years would mean at least 50 odd PhDs coming out of these different topics for AI. But here's one small, which is for privacy of the user. Okay, and the use case is we have elderly people who are generally, let's say alone at home or have minimal care at times. Then they may fall, right? So if there is a fall, there can be a serious injury. Now, the issue essentially is that we can install cameras in one's house. However, the colored cameras, they would suffer from the privacy issue, right? Since it will be recording who the person is and even more finer details around the person. But if we use thermal cameras, then we can actually partially cover the identity of the subject and details of a lot of things around the person and do the essential task, that is always monitor if a person is upright, sitting correct, or has fallen down. So here is original thermal data. Please watch it carefully because it's not as clear as a color video. And here is the reconstruction. So what the algorithm done is it learns only for when people are walking, sitting, or standing. And whenever it encounters someone in a fallen state, it will have a poor reconstruction. When it has poor reconstruction of the signal, then on the bar, on the graph here, we'll see a spike, which tells us, okay, a fall event has happened. Okay. So for example, the person walks in, here is the reconstruction and sits on the chair, and we will notice that now the person is going to fall down. Okay, the person falls down, and we note that here is a spike. Okay. Now, if you notice in the video, the privacy of the person is still preserved. We do not know the details of their surroundings. We do not know who exactly this person is, but we are still able to detect that the person has fallen, which is based on the high error which is here. Okay, so this is a very critical aspect of artificial intelligence, since we know that, for example, our smartphones and other devices, they have these assistants, for example, Siri, for example, Hello from Microsoft, right? So there is a fine line between when too much information is shared with the AI system and when sparse information is shared, which leads to incorrect results, right? So this is something which is being taken very seriously now in the labs around the world. So to summarize my talk, here are the future directions. So AI algorithms need to be cross-cultural. What that means is, let's say I learn an AI system on students at IIT Ropar, and then I would like to test the same engagement detection algorithm on students at NCCU, right? So how can AI system learn the generic representation, which is coherent to the engagement, right? Further, it needs to be cross context. That means I do not always need to train big deep learning artificial intelligence based systems, since they consume a lot of energy. Maybe I can train once and then have very subtle changes based on fine tuning so that I conserve energy power, right? And further, cross languages, we have already seen this in Skype now. There are these beta options where one could do the transcoding. So that's another direction, so that the boundaries between humans, due to the different cultures, that kind of sublimes and it goes down. The other is multi-model, multi-sensor. That is, we not only use, let's say, the camera or this microphone, but we can also use physiological signals. For example, we can use heart rate of a person, which can again be detected, let's say, from the camera, non-invasive. And that can be used to detect different physiological aspects of the state of the person. Further, we need to identify local problems, right? In the start, I said we can have generic systems which are trained on bigger data, and then we can identify local problems to which we can apply these AI algorithms so that they are meaningful, so that they can enrich the life of the users. And last, but by no means the least, is the aspect of the algorithm needs to be ethical, fair, and inclusive. For example, it was published in 2018 that one of the most accurate facial expression analysis system by a big research lab, industrial research lab, is quite biased against females of colors. It always shows them as angry, right? We don't want that, because once this kind of information is used for different systems, it can lead to incorrect diagnosis. It can lead to incorrect decisions. So this concludes my talk. Thank you very much, and I can take questions now. Dr. Rohit?
Yes, Dr. Avinav, myself, Subhas Martha from Ropar. Really, it is a wonderful talk and nice meeting with you after February. I didn't meet you, but this is opportunity where I saw you now. So one question is that how far the AI detection on theft, suppose.
Dr. Martha, if you don't mind, we had planned for the questions after, in the Q&A session, but nonetheless, your question, since you have already asked, I think we can take this question and then move further ahead. Please ask your question.
Yeah, fine.
Yes, Dr. Martha, can you please complete the question?
Professor Martha, you can ask your question.
Yeah, actually, I was looking the application of AI on theft.
Right. So on threat detection, so threat detection has multiple dimensions. Threat can be online, threat can be physical as well. So if it's physical, we can of course have these surveillance cameras which can detect violence. So there is a considerable amount of work which is going on in that direction. However, for online as well, let's say targeting a particular person, trolling a person, and also creating, let's say, fakes of a person, there is ongoing work. There is a need for a lot more, but the good news is that research labs are actively working in threat detection, both online and in physical, to users using different sensors.
Okay.
Thank you, Professor Abhinav. Thank you, Dr. Martha. May I, first of all, thanks for the wonderful talk. And we will take question and answers in the Q&A session. So I would request Professor Dhar if you can stay around till that time. At the same time, once again, thanks a lot. And may I request Professor Pawan to take charge of the proceedings now with the next session.
Okay, thank you, Professor Abhinav Dal, for the very wonderful talk. We learned a lot from it. Thank you so much. Let's move on to the next talk, which is also from AI. This will be presented by Professor Wei-Ta Chu of the Department of Computer Science and Engineering, National Cheng University. National Cheng University is one of the top universities in Taiwan. And let me briefly give you an introduction to Professor Chu. Professor Chu received his BS and MS degrees in computer science from National Jinan University in Taiwan, his PhD degree from National Taiwan University, and he's currently a professor in the Department of Computer Science and Information Engineering, National Cheng University. He was one of my colleagues in CCU, I think 2 years back. His main research interests include digital content analysis, multimedia systems, deep learning, pattern recognition, computer vision. So I think he is one of the best candidates for giving a talk on AI because that is his expertise. He has won the Best Full Technical Paper Award in ACM Multimedia in 2006. He was awarded Outstanding Young Electrical Engineering Award by the Chinese Institute of Electrical Engineering in 2017, the Distinguished Alumni Award presented by National Jinan University in 2014, the Best Gold Member Award presented by IEEE Tainan Section in 2013, and the KT Lee Young Researcher Award presented by the Institute of Information and Computing Machinery in 2012. His list goes on. I don't think I can cover the whole list. So as you can see, he is a very active and very excellent researcher in his field of expertise, and we are very happy to have him online to give us a talk. His talk will be on a study of self-distillation for mango image classification. I think we all love mangoes, and I think we will all love his talk too. Please, Professor Chu, your stage.
Okay, yeah, thank you for your introduction, Professor Chung. Can you see my share slides, share screen?
Yes, we can see that.
Okay, thank you. Thank you so much. Hello, everyone. My name is Weita Chu. I am now in National Cheng University, and I was from CCU. Okay, so although I moved to my new university, I still tightly connected to CCU. So I'm very happy to have this chance to talk to my current research, and I will be happy to have the chance to cooperate with all of you. Okay, so today I would like to introduce one of my preliminary studies on knowledge distillation, especially for the image processing or image classification task. Okay, so especially for mango. Okay, so mango is actually a very highly is an expensive fruit, not only in Taiwan but also in the world. So we produce many mangoes, and we need to grade the mango before it was exported to the consumers. So the best quality mango can sell with high price. So it would be very important to do preliminary classification. And in this year, actually, under the sponsor of the Ministry of Education or the Ministry of Science and Technology in Taiwan, we host we call it AI Cup 2020. It's a competition. So in this competition, they provide a data set, a mango image data set, where we can classify each mango images into grade A to C. That means the quality from the best to the worst. Okay, so basically, because all these images are all mangoes, they look very similar. As we can see here, we can see the grade A, grade B, and the grade C. If you are not the expert of mango, it may be difficult for you to distinguish different classes. And so we can consider this problem as a fine-grained classification problem. And one thing even worse is that because these kinds of data sets were collected by a very cheap consumer camera, so as the mango move along the pipeline, the camera capture the mango image. So we suffer from the problem like motion blur or luminous variance. So it would be a very difficult problem, even if we only need to classify into one of the three possible classes. Okay, so here we would like to develop a deep learning model to do this kinds of fine-grained classification problem. And now we know that now we have many very promising and complex deep learning models that can do very good classification performance. However, these kinds of complex models may not be used in real applications. For example, because the model size is too big, so it is not easy to fit or to store this kinds of model into a mobile device, or the inference time of these kinds of model is too long, so it does not match the real usages. So in this case, to face these kinds of problem, some studies called model compression were proposed. The goal of this technology is to compress a cubism model to complex size. So we would like to compress the complex model into a simpler model. And one of the technology for model compression is called knowledge distillation. That means we want to transfer the knowledge from a complex teacher model to a simpler student model. Okay, so this idea was proposed actually in year 2014. So it's a good idea. However, if we want to do the knowledge distillation, we need to train a large complex teacher model first. So usually in these kinds of technology, people just assume we already have these kinds of teacher model. However, in many different applications, the complex teacher model may not be available in advance. So recently, there is another idea that is called self-distillation. So how about we just start from a simple student model, but this student can learn by himself. Okay, so the idea is illustrate like this. In knowledge distillation, we have the complex teacher model to teach the student. However, in the self-distillation, we only have the student model. So how can the student teach by himself? Okay, so the advantage of this strategy is we don't need the pre-trained complex teacher model, and the performance can be better than itself trained from scratch, or even better than the teacher model. Okay, if we have better design, so we can improve the student model better and better. Okay, and of course, the smaller size student can be applied to devices with less computation power. So the contribution of this work here is we apply the self-distillation approach to fine-grained image classification problem. And based on the idea of self-distillation, we propose 2 additional losses to improve the performance. And we also analyze the advantage of the architecture and show the potential development for it. So here is the main idea of self-distillation framework. So given an image, maybe we can input this image into like a CNN model, like a ResNet. So as you know, the residual network consists of many residual blocks. For example, we have 4 residual blocks here. So we have residual block number 1, number 2, number 3, and then number 4. So theoretically, the deeper residual block learns higher level information, like higher level semantics, and after layers of image processing, theoretically the rest block number 4 learns more information. He knows more. Okay, so in this case, how about we use the deepest residual block as the teacher, and use his knowledge to guide the learning of shallow residual block. So that's the main idea. So here, the so-called self-distillation framework, it's just like for example, we have no teacher. However, the senior student can teach the fresh students. Okay, so how can we do that? Basically, we can design several loss functions. Like, of course, the deepest residual block should output the correct classification result. So this is the first one. The second one is we would like to enforce the classification distribution or the classification result of the deepest classifier should be similar to the other 3 fresh classifier. And we would like to enforce the feature extract by the residual block number 4 that should be similar to that residual block extract, the feature extract by the shallow residual block. So this is the main idea. So here are some definition of these loss functions. Actually, they are quite simple. The first one is the cross entropy between the prediction classification result and the real classification result. And the second part is we would like to enforce a similar classification result between different levels of classifiers. And the third one is the features. We would like to enforce the features should be similar between different levels of classifiers. And for the Mango, especially for the Mango data set, we also consider 2 spatial characteristics of this data set. The first one is the features of images from the same class should be similar. So as we can see here, we have 1 class A image and 2 class B images. So basically, the features of these 2 class B images should be similar. The similarity between them should be larger than the similarity between A and B1 or and B2. So in this case, we can design a triplet loss to consider this characteristic. The second one is we actually have an ordinal characteristic in this data set because we have grade A, B, and C. That means the quality from the best to the worst. So it would be a terrible thing if we misclassify grade A into grade C. Okay, we should give higher penalty to these kinds of misclassification. We can relatively give a smaller penalty if we misclassify grade B into grade C. So in this case, we can design the so-called ordinal loss to penalize different cases. Okay, so here we further design the triplet loss and the ordinal loss. So I will skip the mathematical detail. But finally, we combine all these 1, 2, 3, 4, 5, all these 5 losses function with a linear combination. And we want to verify that by further considering the triplet loss and the ordinal loss, we can get better result. So here is the full diagram of our proposed method. We further consider the ordinal loss and the triplet loss. So about the experimental result, for the training data, we have 45,000 images for training, and we can see the distribution of different grades. So this data set is a little bit imbalanced, okay? A little bit in that balance. And the validation set, we have 7,000 images. And to make the images more balanced, we can do some data augmentation like resize, random rotation, flipped, and normalization. And we only start from a simple student model, that is the Resonate 18. So it's a rather simpler model. And we would like to enforce the self-distillation. So here we can see the experimental result. If we train the Resonate 18, train from scratch, the classification accuracy is around 79%. If we adopt the basic self-distillation, we can achieve around 80%. And we can also combine different levels of classifier to form the ensemble version. So we simply linearly combine the result of different levels of classifiers, and we can get the ensemble result. If we further consider the triplet loss and the ordinal loss, we can get even better results. So here, the observation we make is the self-distillation approach really outperform training from scratch. And the 2 additional losses can further improve their performance. And even naive ensemble method can work effectively on the data set. So this is one advantage of the self-learning method. Here shows the confusion matrix. So we can see that the original self-distillation from here to the, if we consider the triplet loss and the ordinal loss, we can improve, especially class A, okay? Improve class A from from 89% to 90%. And because the numbers of image in grade A is the largest. So in this case, averagely we can get a better classification result. And we can see that we decrease the misclassify the grade C image into grade A from 43% to around 42%. Okay, so here we can slightly improve the performance. So this is one advantage. Another advantage is because now we don't need the complex teacher model. So in conventional knowledge distillation, we need to train the teacher model like Resonate 101. Okay, so it costs a lot of time. Okay, and we can distill the knowledge of this complex model into the simple student model. It takes more than 8 hours. However, if we just start from the student model with the self-distillation, it takes only 2 hours, and we can see the performance is quite similar. Okay, although we save a lot of time. Okay, so this is another advantage. And especially we have the scalability if we adopt the self-distillation. For example, in real usage, we may need to accelerate the inference time. So in this case, we may not use the entire Resident 18 framework. Maybe we can just take for example, the second shallow classifier. That would be faster than the ensemble version or the entire version. And we just pay the cost with only about 1% accuracy drop. Okay, so this is another advantage, the scalability. So here are some sample results. So we show 6 samples here. So can you distinguish which ones are grade A, grade B, and grade C? Okay, so the correct result is A, B, B, C, A, C. Okay, so if you are not expert, actually, this would be a little bit difficult for you to distinguish A, B, or C. Okay, and for me, if you don't tell me the correct answer, I still think, for example, this one, the second one, it looks very good. Okay, right? So actually, the label, the ground truth label, is given by professional farmers. Okay, maybe because they are a little bit damaged here. Okay, so although the color of this sample is not good, but the shape is still good, and maybe it will become a very good quality mango. And here we can see more damage here. So this may be the reason why it is classified as grade C. Okay. So in conclusion, we verify the effectiveness of self-distillation on the fine-grained image classification problem, and we propose 2 additional losses and verify its effectiveness. And yeah, we have several advantages like faster inference time and the scalability. Yeah. So yeah, that's all my talk. Thanks for your attention. I will be happy to take some questions. Thank you.
Okay, thank you, Dr. Chu, for the excellent presentation. I believe that self-distillation will be a very good technique in improving accuracy and doing a better classification on lots of data set. I think we do not have time in this session, but we'll take the questions later on in the final session. So let's move on to the next session. We have the next session is a business-related or industry session. We are very happy to have Mr. Karthikeyan Sattumadavan from Tata Consultancy Services, the Taiwan head of the country head. And Mr. Karthi, before I let me see where if I can share the video. I'm sorry, the slide. Yeah, here it is. Okay, so I hope you can see the slide. This will be presented by Mr. Karthi Madhavan. He is currently the country head of the Tata Consultancy Services, Taiwan. He has over 24 years of experience in business operations, management and growth, delivery unit management, people management and coaching, and international business in IT and services sector across various coaching and international business in IT and services sector across various geographies. Karthi has held several key roles and portfolios in his career. Before joining the Tata Group, Karthi had a very enjoyable and learning sales stint of 4 years in Asian Paints Limited, after which he went on to work as a senior manager in Mobi Apps and Arthur D. Little Company. His special focus was on product development and new product launches in telematics and wireless technologies across India, Europe, and Southeast Asia. Let's welcome Mr. Karthi Karthikeyan.
Thank you, Professor. It's good to be. I was just messaging with Eric that it's good to learn so much, and for people like me who have a challenge of natural intelligence, it's good to actually have a talk on artificial intelligence. So anyway, so I have only one slide. Okay, this is the only slide that I'm going to talk about. But so it will be easy for all of you to recall what I spoke about. But this is also not necessarily only on technology, but I wanted to just touch this few 10 minutes that I'm going to present on the relationship between business and the new AI era, right? So we've all known, all of us are in technology, and all of us have seen how in the last 20 years, I don't know how many students are here who are probably just about 24, 25. But in the last 20 years, technology has really changed the way we live. And in any part of business or in any part of life, there are three very important components that we actually see. So for this group, my request is to view this at a larger and a different perspective of where this AI is going and why actually AI has actually become so important. So if you actually look at it, you have a business context to anything, you have a technology context to anything, and you have a social context to anything. So business is always done within these confines. Life works within these confines. So our mindset till now, I don't know if I think the slightly older generation in this group will understand when during the industry 1.0 was about steam engine, okay, in 1850s. And industry 2.0 came out when people were talking about utilities, when electricity was found, and they said, okay, we can do something with diesel engine, right? Electricity and your diesel and petrochemicals. So the third one, obviously, between when Ford said that I can create any number of cars as long as it's black. It's a very, very famous business saying, and as well as in terms of the supply chain, he said that I can create any number of cars as long as it's black. So that was the first time that a supply chain and assembly line was formed with that principle. And of course, the IT revolution came, and today we are talking about the AI revolution, right? What is it, and what drives this? So if you actually look at it, the business context are four important parts. Okay, the first one is embracing risk. So earlier, all of technology was used to mitigate risk. Earlier, we started using computers and we started using programs, and in computer science, the earlier ones, we were always talking about stored procedures, right? We used to write a procedure, and the computer and the idea of technology was to repeat that procedure, right? The purpose was, I wanted to minimize risk, I wanted to minimize mistakes of humans, and although we are intelligent, we are capable of making mistakes. So that was the driver for risk mitigation. But with AI, like what Professor Dahl was talking about, there are risks now, and the purpose of AI today is actually to embrace that risk, right? Because mitigating that risk is now very basic. Now people are looking at, as the talk here went, that whether it is good or bad, but still people are still trying out. People are still embracing these risks because there are new opportunities with risk. The second one is mass personalization. So this is something that all of you, especially the students, should understand, that the purpose of AI is actually, the fundamental factor came from this one aspect, which is mass personalization. Earlier, as I told you, when Ford said I can create a car which is black in color, that was about mass production and efficiency. But now everybody in this world is now saying that I want to personalize. I'm unique. I want a service only for me. I want a product only for me. So this is the one aspect where AI has really shown that you as an individual can be serviced by the biggest of corporations. One very good example of this, which all of you might immediately relate to, is your Netflix and Amazon, right? They are companies which are using AI, which actually look at personalizing what you prefer. We all log on to Netflix, we all log on to Amazon Prime, but the most important thing is there is a bigger AI engine which is actually behind, which is actually driving your personalized choices. So it is not that, so when everybody says, Netflix, I join in and my wife joins in, the choice of movies that it is pointing to me, and the choice of movies it's pointing to my wife, and the choice of movies it's pointing to my son is completely different. And it's very unique. So this mass personalization is very, very important for all of you to understand that this is where the future is. The third one is, of course, leverage ecosystems. These are all the business contexts that I talk about. This is something which is very important in AI. I think one of the first professors who spoke about this spoke about water and AI, how water is going to be, water distribution is going to be supplied with AI. I think it's just one of the icebergs. Everything is going to be linked. Every system, utility system, your e-governance system, your taxation system, your life system, your health system, whatever it be it. I think all the ecosystems are going to be extremely leveraged on one another. And the last one is, to create exponential value. So this part is most of you would understand with over a period of time as well, that any value that we drive, earlier people said a 20% rate of return is a good value. Then somebody said, no, even a 10% rate of return is a good value. Somebody said, my quality of life is a good value. But today people are talking about creating exponential value, right? They're saying that there is nothing called a mathematical rate of return. If I do something, can I get 1,000% return? Can I get a 5,000% return? Not just in money, I'm talking about anything, right? So in engineering, or in physics, I'm a physics graduate. I'm not an engineer. I am a science guy. So we talk about the input and the output, right? In terms of efficiency, right? So there will be wastage of efficiency, and when we talk about 100% input and a 200% output, or 100 input and a 200 output, which gives you 100% efficiency. Now today people are talking about, I will give you only 100, but I want a 5,000 output, or I want a 10,000 output with crazy efficiency rates. So that is something that can be, that is the need for AI. There are four, these are called the business pillars: embrace risk, business personalization, exponential value, and leveraging ecosystems. There are four technology pillars for this one, which of course the first pillar is intelligent. That is extremely important, because the difference between intelligence and normal efficiency is that it is able to decipher what to do at that context of time, and what is applicable at that context of time and space. The second, of course, is cloud. I think everything is moving towards a cloud. I don't need to expand more on this. But this is something which will say that physical boundaries and physical infrastructure going forward will not be a constraint. So this is something that is going to be very key in the future. Automated, I think this is a given. Very soon you might find, I think one of the professors mentioned this. Sometimes I feel a little scared. I feel that, many of you might not have been born, all the students, but when Terminator, the first movie, came in 1987, I never thought that it'll actually become a reality. So now we will very soon see AI starting to think for itself. right? One of the professors was saying self-learning. So now we are going to look at not only artificial intelligence, but automated artificial intelligence. Now, so this is the leap of technology, and we have to just live through it and go through it, or sometimes ride it. And of course, the last one is agile. So these four are the technology pillars. The last part of it, a couple of minutes on this, is there is always a social context, right? We are all engineering people, we are all technology people. But we always should not forget there is always a human a factor to whatever we do. We are not machines. Although we talk about machine learning, the purpose of all this is to serve the human race. There is a social context to it. So these three inside the inside part of the sphere, which is resilient, adaptable, and purpose-driven, I think these three are the most important part of why are we doing this? Why should we go AI? Why should we go technology? Why should we go engineering? Why do we need to engineer anything, right? So there has to be a purpose of whatever we do. We cannot do technology for technology's sake. Everything, every code, every invention, every bit of a seminar or whatever it may be has to have a social purpose to it. That it has to serve the larger humanity in a way, right? The second part is adaptability. I think this is a given. You cannot say that this is the way that we do things anymore. It has come to a place where adaptability is one of the most important part of any particular requirement, be it technology or be it business. And the last one, I'll close with this, is resilience. I think we live in a very challenging world situation today, where health concerns, technology concerns, rapid growth of technology, financial concerns, economic concerns, social concerns, and spiritual concerns. But what really goes through with all of this and is the thing of resilience. Do we develop something or any program or any faculty of engineering, can it show the resilience that it can stand through the test of time? I think so that is the key. So I leave with this. This is just one slide for all of you to have to actually look at this and think about this. My talk was specifically on the business context of what is the future and how it applies to AI. I thank you all for the opportunity, and it's a pleasure to listen to all of you. As Dr. Eric was saying, we'll any questions are there, we'll take it at the end, and I will stick to the presentation and wait for it. Thank you, Eric.
Thank you, Mr. Karthikeyan Sethumadhavan. Thank you so much for the excellent view from the business perspective regarding intelligent, cloud, automated, and agile. Thank you so much. We'll take the questions later on. Let's move on to the next industry talk, which will be given by Mr. Ashwin Prasad. Let me briefly introduce Mr. Ashwin. Ashwin is my very good friend. He's from Tech Mahindra. He's currently the business head of Tech Mahindra in Taiwan. He has 10 years of experience with successful track record of leadership and of strong business acumen with expertise in conceptualizing robust plans for market development in different segments at national as well as international levels. With extensive background in forecasting regular sales and set up and achieved assigned quota for inside sales, monitored and grew quoted revenue, leveraging best-in-class inside sales tools, technology, and strategies. He has made a mark in the industry with numerous achievements and recognition. Mr. Ashwin Prasad has experience in building relationships with key decision makers and provided customers with right solutions for their needs. He is adept in interacting with key decision makers, framed their requirements specifically in pretender situations, prepared proposals independently, and represented company for techno-commercial negotiations. We are very happy to have Ashwin online. The talk title will be Artificial Intelligence, the Real Possibilities. Mr. Ashwin, please.
Thank you. Thank you, Pawan, for that warm introduction, and very good morning, good afternoon to everybody from India and Taiwan. Very nice to see such a large presence, and thank you for inviting me as part of this event. So, Pawan, are you able to see my presentation?
Yes, I can see the presentation.
Okay, wonderful, wonderful. Okay, so a lot have been already talked about AI. So I think all the earlier speakers and leaders have covered majority of it. So I will try to do justice in my short time of 5 to 10 minutes. I've made a brief presentation. I will try to place the perspective from my standpoint in artificial intelligence, and also what we are doing as part of Tech Mahindra, and what are the partnerships we have done in this area, and how we are going to proceed further. So I'm part of Tech Mahindra for close to a decade, and now I've been placed in Taiwan and managing the business here. Must admit, so far my journey in Taiwan have been very enriching, very fruitful, and I think India and Taiwan as two continents bring really good value on the table, and I foresee a very good partnership between the two subcontinents. So as you all might be aware, right, like in the early 1990s and 1980s, when electricity has just boomed, and that area of time now in the last 20, 30 years, in any corporate, any industry, any business, we cannot imagine to do business without electricity. Now, AI is being termed as the new electricity by Andrew Ng, and now going forward, it will be very difficult to imagine doing the business, because everything is now so connected and so technology oriented that it is now framed as the new electricity. And the reports from Gartner very clearly indicates that AI augmentation will at least create 2.9 trillion dollars value of business value in by 2021. It can be split in agents, smart products, smart devices, automation, and there's a huge business value that we will foresee as part of AI as we go forward. So the chart that it actually shows you the split between what was there in 2017 in when we talk from a business standpoint, and what you will foresee by 2025. So it's a very promising market, and the facts and figures says that at least 133 million new jobs will be created. So it's a good news, though there are pros and cons when we come forward between humans and machines. But if you see from a positive standpoint, if you see from a very positive outlook, we foresee that we will at least have 133 million new jobs created by AI by 2022. And one important point that we all should note, the the methodology, the job area, the job demand, the job skill set is continuously varying. So if you now see the reports, at least from the US market, the job skill set, the highest valued jobs is a machine learning engineer, an agile coach, and a data scientist. So if you see your years which have past gone for last 4 to 5 years, we never saw this kind of demand in the market. But now even a graduate, after he or she pass on from the college, are well trained in areas like machine learning, data scientist. So these are the high demanded jobs as per for the World Economic Forum reports, and future is very positive. Focus areas majorly because there are multiple dimensions to AI. The majority focus right now as a company, as a corporate, at least from a Tech Mahindra standpoint, we are majorly focusing on five big buckets, right? One is the healthcare, second is the agriculture, Third is the education. Fourth is, of course, the smart cities and infrastructure. And fifth is the transportation. So these are the big areas where we as a company are investing a lot. And when we talk about healthcare, right, everything is so uh, changing so rapidly that even the X-ray reports, even the radiologist will see a very automated, very advanced operational systems, and that will make the reports very effective. And healthcare has a big scope for the benefit of the human life and the advanced doctory. So it has a very massive role to play. So AI, so we are investing a lot in this space with new technologies. And agriculture, of course, the farmers, the soils, the precision agriculture has a large amount of play. And smart cities, we are investing a lot, at least from a surveillance standpoint, and also how can we mitigate the crime across our society, right? So this engraving technology and AI advancement is actually benefited in every industry you foresee. And these are the big bets where we are actively working on currently as a company. And just to give a little more broader perspective, I also want to share that as part of AI initiative of Tech Mahindra, what we have done is we have launched Makers Lab initiative. Makers Lab is something which we have launched in at least 8 to 9 countries across the world right now. India being a big market, followed by Germany, US, and China. Uh, Here, what we are doing as part of Makers Lab, we are actually taking right skill sets, right small projects. We are training the employees. We are training the fresh graduates who are willing to learn more on AI. And we are actually doing partnerships with universities. We are doing partnerships with academia and also corporates to make effective solutions for the benefit of the society. So this is one of the very important initiatives that we are running lately. And in Taiwan, we are planning to launch this very soon with one of the universities. Our approach is very simple, right? Our approach is automation anywhere. So it is divided into multiple setups again, right? Like we are investing on text analytics, machine learning, like what Karthikeyan have just explained about the example of Netflix, where somebody like Netflix can actually give you what is your choices of the movies, which can give you your options. Then we are investing a lot on bots, chatbots, because every website nowadays requires advanced chatbots. And so we have invested a lot on chatbots. We have collaborated with big corporates like IBM in this space. Then we are investing a lot on automation process. So all the operational process so far, which we used to follow within a university or within a corporate or within a business segment, say you call it a human resource process, you call it a supply chain process, or you call it a financial process, every process is now getting very automated. And especially in all the banks, you will see that all the processes within the banks are getting very smart, very advanced to kill the manual effort. So that is one area where we are investing a lot, and we believe that this space will only benefit both the corporate and also the key end consumer. Some service catalog we have now reached a point where we have good solutions in this segment. One is the virtual agents, where we are saying that we help you with the advanced bots. Then is the machine learning and numerical analytics. And third is the text analytics. Fourth, again, is very important, the computer vision, right? At least in this period of COVID-19. So who is wearing mask? Who is not wearing mask? This kind of object identification, this kind of face recognition, this kind of image classification. Like I saw that one of the professors also showed in detail the advantages on image classification and video analytics. So this is one more bracket of computer vision where we are investing heavily. And the final and the fifth bucket is basically more on the process automation, right? As I was telling you, the examples of banks, front office, back office banks, machine learning, driven process automation, OCR, ICR. So these are other areas where we are investing heavily, where we have reached to a stage where we can actually have the solutions incorporated. Some of the use cases and some statistics and figures for the benefit of everybody. So we have 9 makers lab globally now with 5 automation lab centers. We have a huge investment of AI labs in Bangalore in India and also in Fremont and in Germany. And we have invested close to $5 million in the space of AI capability building. 500 machine learning and AI certified professionals are now in-house in Tech Mahindra. And it is only possible what we have realized in this journey when we started our work on AI from 2016, 17 to 2020. What we realized is that we cannot do anything or everything individually. We always believed in having good partners on the table. We always believed in working with right industry professionals. We always believed in training the skills and upskilling for the employees and for the fresh graduates, because at the end of the day, the goal and the motive of doing all this is only for how can AI as a technology benefit the society for at a overall perspective. So that's a brief story about Tech Mahindra. But if you have any specific questions, I'll be more than happy after all the speakers finish their sessions. We'll be more than happy to take that. Over to you, Pawan.
Thank you, Ashwin, for the wonderful talk on how Tech Mahindra has invested in AI. And I believe Tech Mahindra will play a major role in the future as far as AI is related. Okay, now moving on to the next session. This is being given. So now we are moving on to hydraulic engineering. Okay, so the first talk will be given by Professor Chaofang Li, who is currently a research professor in the Tainan Hydraulics Laboratory, National Cheng University, NCKU. Let me briefly introduce Professor Li. Professor Li is actually a very senior professor. Actually, he already has just retired from NCKU, and he has achieved remarkable achievements as far as hydraulic engineering is concerned, specifically about the ocean structures. So how wave hydrodynamics affect ocean structures. This is his expertise. So we are very happy to have him online. Let me briefly introduce. He got his PhD in 1986 from the Oregon State University in the US. And his research interests are interaction of waves and floating structure, interaction of waves and porous structures, interaction of waves and submerged structures, wave on poroelastic seabed, wave-making theory. He has been in NCKU right from associate professor to professor. He was also the visiting professor way back in 1992 in the Kyoto University in Japan, and he was also the visiting university at the University of Queensland in 2000. So recently, he also wrote a full book on his expertise, and we are very happy to have him online. His talk will be an overview of wave force hydrodynamics on ocean structures. Professor Li, please.
Okay, thank you, Dr.
Dr. Eric, we can't hear this presentation. I think his phone of the mic is on mute. Can you please unmute yourself?
Excuse me, Professor Lee, maybe you should turn on your mic. You didn't turn on your mic. There should be a button to turn on the mic. Yeah, now we can hear you. Yeah.
Hello, is it okay?
Yeah, it's okay right now.
Yeah, now it's fine. Yeah, thank you.
Now we go back to the PowerPoint here. The figure shows a typical ocean structure in the ocean, but the question would be, we need to know the wave field as well as the motion of the structure. Therefore, if you want to study this problem, let's look at next page. I want to say is that if we want to know the entire motion of the problem, we need to solve the wave field as well as the motion of the structure. That means we are looking at waves that has a motion of the structure. And of course, for structure side, we can solve the structure equation. I want to say is that when we started to study of this kind of problem or in this professional field, the basic wave mechanics would be related to the fluid mechanics. But I want to say is that we are not just looking at the fluid mechanics. We should look at the water waves related to fluid mechanics. We can look at this YouTube film here. Okay. For the structure moving in one direction, there will be a regular normal fluid mechanics. But in waves, because the motion of water waves is oscillatory, that means relatively we are looking at the fluid mechanics in the continuous way. Let's continue. No, film 那个影像 continue。
好像没错，这样。
就刚刚那个 film 再重播一次。
我这边，我现在看不到。
Continue。
可以，上来去。
Therefore, the structure will move to our left, then the fluid flow would be quite a lot different from a unidirectional flow. That's what I'm going to point out in this page. And the next, this shows a propagating waves. Let's also look at the movie. It shows here. Normally, we are looking at the water waves, which is regular wave and is moving in its steady and periodic motion. But for the problems in the interactions of waves and structure, we are not just looking at the waves. Stop. We are not just looking at the waves. We still need to know the effects from the structure. Therefore, for the wave theory, we'll also be looking at a different way. We should be looking at a wave theory that has effect from the structure. Okay, so we need to know the wave forces acting on the structure so as to calculate the motion of the structure. At the beginning of the study, basically, we want to look at the wave motions without the deformation, without effect from the ocean structure. Therefore, we would say that it's a small body wave force. It's the simple case for water waves, for using water wave theory to calculate the wave force acting on the structure. I think we can also look at the, I think we skip it. Next page. And then the next step would be the wavemaker theory, because we need to know the effect from the structure on the fluid flow, and the motion of the structure will generate a kind of water waves. That means we need to know this basic wavemaker theory so as to apply to the interaction problem. And in this film here, we are looking at a kind of directional wavemaker. And if we look at the motion here, we notice that the movement of the wavemaker will generate a kind of waves propagating away from the structure and will form a different kind of water waves. And we also notice that this wavemaker actually is composed of many small elements or small wavemakers, so as to generate this kind of a motion here. And then after we know the wavemaker theory, then we can apply to study the problem so-called wave refraction. That means in the coastal area, we notice that the wave propagating far away from the structure come into the structure and then attack on the coastal structure, and then will generate a kind of wave refraction. And this is the problem after the wave generation. And we can also look at the YouTube here. Please notice that a kind of total refraction will be generated. Okay, there's also a sound in the laboratory. And the wave is generated and then will hit the end vertical structure, and you notice that a kind of total reflection waveforms will be generated. This is a problem after the wavemaker one. And then after that, the problem we need to know would be this wave diffraction of a vertical cylinder. And the results, we can check the film here. Yes. What I'm trying to show is that it's an animation of a waves acting on a vertical cylinder. The waveforms around the vertical cylinder. The student here is helping me to solve. Yes, that one. Wave diffraction. If not, we just skip, or we just yes. Just we just skip because we don't have enough time. Okay, go back to this one and the next page. We skip that one because it does not work this time. Sorry. And then we need to look at the wave radiation problems. It's different from the one different from the previous one is wave diffraction. That means waves, propagating waves come in and then act on a fixed structure. For this time, it's motion of the structure and generate water waves. And then we can look at this interaction problem. This is actually a motion of a floating duck. We can notice that the waves acting on the duck and the motion of the ducks. It shows the problem of this kind of wave and structure interactions. Okay, and now we have some other kinds of different structures. For this one, we have a porous wave, porous structure. A porous structure in the wave field. The application of this one would be fission submerged cage. That's it's a fishing cage. Actually, it's composed of a net and some steel structures and the fishes in it. Okay. And also, we need to know the motion of the fishing cage. Therefore, it would be the application of this kind of porous wave theory. And then we also have a deformable structures. For this one, let's also check the film here. For this kind of deformable or flexible structures, the application would be to apply the for this time it's seagrass or sea plants, and we utilize that to use that as a kind of protection to the ocean structures. Okay, then I think this would be the last part. I would like to say would be the time domain wavemaker theory, which is different from the steady periodic wavemaker theory. And in this subject, we proposed an analytical solution to the problem so that we can establish a mathematical model and to simulate the problem of wave motions. For this one, we can say that we call it a time domain. That is that initially the water flow or fluid is still, and then because of the motion of the structure, and then that will generate waves. I make the film to be repeated, but I can stop in the middle. We will see by the side of the glass wall, you will notice that initially it's still and the waves generated and then will reach a steady periodic. So this is, I call it a time domain wavemaker theory. And then by applying the solution method to this kind of problem, we can also solve a different kind of problem. For this one, is we say the water oscillations induced by initial elevation. Initially, the water surface is not still, it has a kind of slope, and that it is because we have a strong wind blow during the winter, so that the water level inside the harbor has a kind of slope at the surface. But then after the wind or wind blow stops, the surface started to oscillate. And we can have the mathematical model to simulate the results like that. That's calculated from our analytical solution to the mathematical model. And then another kind of problem would be a kind of waves generated or induced by bottom movement. Or we can say we are familiar with a kind of a tsunami generated. And our mathematical model can also give a solution to this kind of problem. Of course, now we have a very simple, it had a bottom move upward and will generate water waves at the free surface, and of course that will propagate toward the outer direction. And then what we have seen so far is two-dimensional problem, and the method can also be applied to more realistic three-dimensional extensions. Okay, and I think I just simply show some results. This page, it shows we have seen this kind of directional wave maker. It composed of many elements, and in the theory, at the beginning, we will look at this kind of discrete element to be a continuous one, so that let's look at the result here. Okay, so on our left-hand side is a continuous motion of the wavemaker. Of course, realistically, it's discrete. It's not continuous but for mathematical model, it can be continuous, and then to generate water waves. We need to notice that it started from initial still state. Okay, and of course, we want to be more realistic. That would be that the wavemaker will be discrete. For this one, it's link. Okay, for this one, we notice that on the left-hand side, it's not a continuous function anymore. It's a simulated, more real, discrete, more element wave maker, and it also can generate waves. For this case, we are using simply a total reflection for the boundaries, and we can add some other boundary conditions so that we get better, less without reflections from the boundary. Okay. And for the tsunami case, for the wave induced by bottom movements, we can also have a three-dimensional case. And they show some representative results here. Now it's three-dimensional. It's a simple, a rectangular bottom movement upward to generate the water waves, or we can say it's a kind of tsunami generated results. To get more realistic results, if we have a bottom motion, it can be a very complicated motion for each part, and then will generate a total more realistic tsunami waves. I think that will be the end of my today's simple report. Thank you for your attention.
Thank you, Professor Lee, for the wonderful and very interesting talk on the impact of waves on ocean structures. I think we learned a lot, and with the very beautiful simulations. Let's go on to the next talk. Dr. Rohit, would you like to share it? Thank you, please.
Thank you, Professor Eric. And the next talk in this webinar or workshop is titled as The Role of AI in Planning of Groundwater Development. And this talk will be given by Professor Deepak Kashyap. Professor Kashyap is a professor of civil engineering at the Indian Institute of Technology, Ropar. He is also the Dean of Faculty Affairs at IIT Ropar. Professor Kashyap had spent his entire life working in the area of groundwater development, planning, management, and hydraulics in general at the Indian Institute of Technology, Roorkee, which happens to be one of the oldest engineering and technology university of Asia. Professor Kashyap is a well-renowned expert in this area, and we are delighted to have him with us today. Thank you, sir, for coming.
Thank you, Rohit. Thank you for the kind introduction. I'm trying to present.
Yeah, we could see your screen just now. So I think I think he just got disconnected, so we'll just wait for him to come back, Professor Eric. So we'll just wait for a minute. I think Professor Kashyap is probably got disconnected. So yeah, I think, sir, you are back. You are muted, Professor Kashyap. You are muted.
Could you have my presentation presented?
Okay, fine.
I'll try to present it.
No, that's absolutely fine. So let me just do that.
Okay, just wait a minute. So I'm sharing my screen now.
Okay.
And
yeah, we can see your screen, so you can.
Right. So how do I go to my desktop?
So this just go to the presentation, please.
Stop. Okay. Let me see. Okay, link for schedule for this.
No, just go to your presentation. It must be on the desktop. Yeah, you can,
okay.
Otherwise, I have the presentation, sir. With
okay,
me.
if you could do that, that would be helpful.
Okay, then can you stop the presentation so that I can do it?
Yeah,
Thank you, sir. Let me present.
Thank you, Dr. Rohit. Thank you.
Just a minute. I'll present it, and
yes,
I'll.
Thank you.
Yeah, Professor Eric, can you see the presentation?
Yes, I can.
Yes, I can see it.
Go to the presentation mode. Yeah. Right. So I'm going to talk on the role of AI in the planning of groundwater development, with specific emphasis on the agricultural aspect of it. That means the groundwater primarily being used for improving the cropping patterns. Now, this was taken up a few years back as a doctoral research program of one of my students, Dr. Susmita, who's currently a faculty at NIT Silchar. So I must mention in the beginning that water resources and groundwater, more specifically, has been rather a late joiner in the AI bandwagon. We have been more mechanistic in our approach, but lately there has been a realization that there are additional advantages to be accrued by synergically joining the mechanistic approach with the AI technology. So that is what I'm going to discuss in the next few slides. Yeah, Rohit, can we go to the next slide? Yeah, so first of all, before I go to the joining with the AI, I'm going to talk of our present state of art. That means the mechanistic approach primarily, which we also call as simulation strategy. So we have a mechanistic groundwater flow model, and in the planning context, we link that simulation model to an optimizer with an objective of arriving at the optimal usage of groundwater. So next, please. So here, if I may briefly introduce the mechanistic groundwater flow model. So this is the flow model which is derived from the basic mechanics. So we have a simulation model. We shall shortly see the structure of simulation model. It receives the initial conditions, boundary conditions, parameters, and the forcing function, and produces head fields at advancing times. And then the head fields are processed through a post-modeling processor to arrive at the state variables which are relevant for planning, which are termed as planning state variables. So this essentially means that for an assigned forcing function using the simulation model and the post-modeling processor, we are able to arrive at the planning state variables, which can help us in determining the feasibility of this forcing function. Next slide, please. Yeah, so I'm going to just talk briefly of the simulation model. So it is a mechanistic model wherein a lot of physics is imbibed, physics primarily related to micro level instantaneous mass balance coupled with a few auxiliary equations. And this results in a governing differential equation. And the forcing function here, W, this in the agricultural context is related to the crop areas or the crop area vector. So as I've shown over here, this forcing function W is a function of crop area. So this means that for any given crop area vector, we are able to compute the forcing function and solve this differential equation to project the head field at advancing times. So this is how we go about in the simulation model. Next, please. So now the agricultural forcing function, which I was talking of, that means the forcing function as imbibed in the governing differential equation related to the crop areas. So we have the crop areas, and we have an agronomic model and a hydro-environmental model, and which produces the forcing function, which goes as input into the governing differential equation that we looked at in the previous slide. So this is the broad structure of the current approach. Next slide, please. So the planning state variables which we talked of could be the depth to water table, the lateral recharge from hydraulically connected rivers, seawater intrusion, static reserves. You know, these are all the state variables which determine the feasibility of any plan. So using the model that I just discussed for a given forcing function, which is derived from the crop areas, we are able to compute all these state variables which may be relevant for the planning. Yes, please. Next, Rohit, please. Right. So here I have depicted pictorially a composite groundwater agricultural model. You know, this is a simulation model plus comprising a few other sub-models, pre-modeling processor, post-modeling processor. So what it does is it receives crop areas and invoking all these other inputs, it computes the planning state variables. So this, let me elaborate what it really would imply. This means if we plan to raise certain cropping pattern in a basin, then this is the crop areas. Then using this composite model, we are able to project the planning state variables. So this means if we raise certain cropping pattern or implement a cropping pattern, then the irrigation corresponding to those crops are the irrigation is derived from groundwater along with from the canal supplies, and that groundwater withdrawal would lead to certain water table depths, and certain stream aquifer interflows, certain seawater intrusion, and so on. So all these are computed over here. So this can help us in determining the feasibility of raising the stipulated or the trial cropping pattern. Yes, please. Next. So now the next step is to link this with an optimizer, wherein we define an objective function, which is a function of crop areas, and we want to maximize the net benefit from that cropping activity and subject to certain constraints on the state variables. So the two state variables which I have taken here for illustration are the depth to water table and the recharge from the river into the aquifer. That means how many meter cubes of river water are inducted into the groundwater as a consequence of lowered water table triggered by the proposed cropping pattern. So we may want to assign certain constraint. That means the depth through water table, say for example, may not exceed beyond 20 meters. This is just an example, but in generic mode, it could be D of A less than dm, some prescribed upper limits, and similarly the lateral recharge from river into the groundwater being less than certain quantity. So typically it may be zero. Because especially in Indian context, groundwater is perhaps the only good quality water resource that we are left with, and rivers are relatively polluted. So to preserve the groundwater quality, we wouldn't want the river water to be induced or laterally entrained into the groundwater. So this is the constraint which would ensure that the lateral recharge from the river as a function of the cropping area vector being less than zero. And so this is basically an optimization problem where the state variables as appearing in the constraints inequalities are derived from the solution of the governing differential equation or the mathematical model which I talked of earlier. So this approach we call as the linked simulation optimization approach, and this has been working quite well for planning of the optimal crop areas, which would restrict the state variables to their respective prescribed limits. Yes, please, Rohit, next. So now lately, we have been finding some operational issues with the linked simulation optimization approach that I just presented. The first is the computational cost. Now, this might sound paradoxical in the present era of cloud computing, but if we, as we shall do, look at the kind of computational effort, computational demand of LSO, that may become prohibitive, especially at the field office, where the computational facilities may be relatively limited. So this is one aspect wherein AI can help us in moderating the computational demand of the LSO algorithm that I just discussed. So the second is the composite model that we discussed may have some inadequate parameterization due to certain deficits which may be derived from the deficits in science or the deficit of database. So these are the two motivations for linking the LSO practice, which has been in vogue in the management, in the groundwater management state of art with AI. So we shall briefly look at this synergic joining of AI with the LSO. Yes, please, Rohit, next. Yeah, so the motivation of the linked ANN optimization. Now, if you notice, earlier we were calling it linked simulation optimization. Now, the simulator, which is the simulation based upon the differential equation solution or modeling, that is replaced by ANN, artificial neural network. So the first is that the state variables for sequentially modifying A are queried from relatively computationally inexpensive ANN model. See, in the traditional LSO model, during optimization, the crop area vector, which is comprising the decision variables of the optimizer, they are sequentially modified algorithmically and corresponding to every modification of A, the state variables, which we have talked about, the depth to water table, the lateral recharge, they are queried from the LSO, which becomes computationally very expensive. So in this approach, the linked ANN optimization approach, the state variables are queried from the ANN model, which is far less expensive. And so this would lead to reduced computational cost per query and hence much reduced total cost. And secondly, possibly a more realistic querying of the state variables D and Q corresponding to the algorithmically varying crop area vector. Right. So yes, Rohit, next please. So this is now what we call as an ANN based groundwater model. So the input here would be just the crop areas, and we have a trained ANN architecture, and it directly provides state variables. So you may notice there are no initial conditions, no boundary conditions requirement, no parameters. All of them presumably would be represented or depicted in the weights of the ANN. So weights would represent all other information other than the crop areas. So for the given crop areas, the ANN based groundwater management model would directly provide the state variables. And this is computationally far less expensive than the more elaborate modeling that I just discussed. Yes, please. Next. So the ANN models of D and Q. If you would recall, there's a depth to water table as a function of the crop areas, and Q is the lateral recharge from hydraulically connected river, again as a function of crop areas. So these ANN models are relevant, though we would like to say our system, groundwater flow system, is relatively well understood. But in spite of that, these ANN models may be relevant because of the reasons which I just talked of. That means to implement economy in the computational demand. So now to develop these ANN, so there would be two ANN models. The first one which links the depth to water table to the crop areas. The second which links the lateral inflow again to the crop areas. So we would need the sample data of crop areas vector A versus D and Q. Now, in the present scenario, we require really a large database to be able to develop credible ANN models for these two state variables D and Q. Now, at present, unfortunately, such databases do not exist. And so the recourse can be taken to develop the database by conducting numerical modeling or simulation modeling. So simulation models are used to generate the data of the state variables D and Q for several arrays of the crop area vectors A. So these data then can be used for training the ANN models, which subsequently could be linked to the optimizers for arriving at the optimal cropping pattern. Yes, please, Rohit, next. So this is what I have depicted. Let us say this is a typical ANN structure. So the inputs here would be the crop areas, A1, A2, say AN, and the outputs could be the two state variables which may be of interest. But of course, here for the sake of simplistic or for the sake of comprehension, I'm depicting only two state variables, the depth to water table and the lateral recharge, but there could be several others depending upon the local compulsions and the local logistics. For example, in a coastal aquifer, the seawater intrusion would be a very important state variable. So what it means is if we modify the cropping pattern, this would modify the pumping pattern, which in turn would modify the water table position and which finally would determine a new seawater intrusion. So if we increase the crop areas, this would lead to increased pumpage and hence increased seawater intrusion. So the increased seawater intrusion along with other state variables could be computed corresponding to any trial cropping pattern vector. Yes, please. Right. So the planning process could be like this. We have the crops, the feasible crops in that area, the zones, the objective function constraints. We have an optimizer which queries the state variables from the model several times and then finally produces optimal crop areas. So here the computational cost here could be large if we go for simulation model, but the computational cost would be much reduced if our model is actually an ANN model. But the catch is if we go for an ANN model, our optimality would be only approximate because the sequentially generated state variables would be only approximate since the model is approximate, the ANN model. Yes, please. Next. So now what we tried doing was a synergic joining of the simulation and the ANN models. So now we have seen the benefits of both. The simulation models are expected to be more realistic because they follow the mechanics and physics of the system, but they are expensive. ANN models do not follow the physics, so they could compromise on the accuracy of the state variables, but their computational demand is far less. So what we have tried to do is to synergically join the two approaches. So this synergic joining comprises two steps. The first step is obtaining a near optimal solution. Now, in this step, essentially, bulk of the optimization is conducted. That means we reach what we can call as a near optimal solution, invoking the ANN-based models. So we start from the basic information and link it to an optimizer, which queries the state variables from the ANN-based flow model. And this is done several times algorithmically during the optimization process. And it produces what we can term as nearly optimal solution, nearly optimal crop area vector. So this would be computationally very fast because as I already said, ANN may just take a few seconds of computer time. So very quickly, we are able to reach a near optimal solution. So in the next step, yeah, Rohit, can we go to the step 2? Now we link the optimizer with a flow model or a mathematical model rather than the ANN model. So with the advantage is now we are not compromising on the accuracy of the state variables. So now the initial solution which needs to be prescribed for most of the optimizers. Now we start from the near optimal solution which we have already obtained in the preceding step. So our now search is going to be very restricted. So the optimizer now would be querying the state variables from the mathematical model of groundwater system a few times only, because we are already close to the optimal solution. So there would be a restricted search requiring only very limited querying from the more expensive simulation based groundwater flow model. So this way we are able to reach the optimal. Yeah, just the preceding slide, please, Rohit. Just preceding. So quickly, we are able to reach the optimal solution. So this final optimal solution would be now based upon the state variables which are computed by mathematical modeling and hence are expected to be more accurate. So here we have, by this synergic joining, we have been able to accomplish both the objectives. We are able to economize on the computational demand, and at the same time, our final results are not compromised on the accuracy. Yes, please. Right. So this actually was applied to a large basin lying between two rivers, Yamuna and Hindon, in the western UP. So a finite difference based simulation model was implemented and two zones were prescribed, two zones of near uniform cropping patterns. And a flow model was calibrated and linked to an optimizer for implementing the planning process, which I just discussed. Yes, please. Yeah, so then through ANN, we linked first it to we linked the optimizer first to a simulation model and then to an ANN. So for the development of ANN, we generated these data by numerical modeling. That means we prescribed several combinations of these areas and correspond. Sorry, okay, sorry, I was muted for a while.
Yeah.
So, yeah, am I audible? Hello?
Yes, Professor.
So we generated corresponding to several crop area vectors. We generated the depth through water table and 4 components of the recharge from the 2 rivers. So these are essentially the recharge from Yamuna during pre-monsoon and the post-monsoon periods, and similarly from Hindon. So these 5 components of the state variable vector were generated corresponding to several combinations of the crop areas. Yes, please. So using this data, we generated ANN models. Initially, we tried to generate or develop a single ANN model capable of simulating both the state variables D as well as Q. But that turned out to be, it was not really working. We couldn't reproduce the simulated data. So we decided to go for 2 separate models. One, a model for the depth to water table, the other for modeling the lateral recharge from the 2 hydraulically connected rivers. So these are some typical results for the generation of ANN model for D, the depth to water table. Right. Yes, please. Next. So similarly, these are some typical results for generation of ANN model for lateral recharge from river Yamuna during pre-monsoon and post-monsoon. So these are for Hindon. Yes, please. Next. So then, here this is the result of optimization. The 2 ANN models for D and Q were linked to an optimizer, and then these are the crop areas fractions expressed as percent of geographical areas. So these are the optimal crop areas as determined from the ANN optimization model. So the maximum depth to water table is 20 meters, and as you can see, the lateral recharge from the true hydraulically connected rivers, the four components are either negative or zero. What it means is either there is no stream aquifer interflow, or there is a lateral outflow from groundwater into the river. So we are not letting river water enter into the groundwater, and thus we are able to preserve the groundwater quality. Yes, please, next. So now here, I can kind of highlight the advantage of using ANN modeling over the simulation modeling. So during optimization, this state variables were computed about 3,200 times. That means the crop area vector, which is the set of decision variables, they were algorithmically modified 3,200 times during the optimization process. And the computer time in the linked ANN optimization modeling was 10 minutes, the total optimization time. Whereas in the linked simulation optimization, wherein we used a simulation model, that means based upon solution of governing differential equation, the total time was 3,200 into 45 minutes. So this kind of time would not have been available, especially at the field offices. So these problems are then taken care of by compromising on the rigor of optimization. But when we link the ANN models for computing the state variables to the optimizer, then the total time is just 10 minutes. So it is a huge saving on the computational demand. And as a consequence, we are able to implement more aggressive constraints, and we can include additional features into the objective function. Yeah, next slide, please. But there is a catch. The catch is as I already said, the accuracy of the state variables. Now, if I can go to the previous slide, please. Just here, no, the next one, please. Next one, please. Next, yeah. Here you can see the maximum depth to water table is 20 meters. It just honors the constraint. The constraint is activated. But when we check, next, please. Yeah. So now, next, please. Next. Yeah. So now when we check the results obtained by the ANN modeling linked to an optimizer, and when we check the results by mathematical modeling, we find that the depth to water table is more than what is computed there. Instead of 20 meters, now it is turning out to be 23.4 meters. That means the constraint is violated. And this is because of the compromised computation of the state variables by the ANN model. And similarly, the lateral recharge components are also positive. So we go to the second step, which I talked of. That means now we link the optimizer with the hard model. That means model based upon numerical simulation. Yeah, next, please. So this is what we call as fine tuning of near optimal solution by mechanistic. Okay, it's not mechanical, it is mechanistic model. So now we link the mechanistic model with the optimizer, and now we restrict the range of the cropping pattern. But because we already have reached near optimal solution, so the search is only now, say, within a small range, say from 90% to 110% of the respective near optimal crop areas. Yes, please. So then, we get the optimal solution, which truly honors the constraints, the depth restricted to 20 meters, and all the lateral recharge components either negative or zero. That means we are not letting poor quality river water threaten the groundwater preserves. Yes, please. Right. So this way I've tried to present, although, traditionally we like to think in groundwater fraternity that our systems are fairly well understood. We know the physics fairly well, and we have robust differential equations which can be solved, which can be linked to optimizers to arrive at, to address the planning issues. But now, as I just illustrated, the mechanistic approach for the groundwater planning works well, accepting the following operational issues. One is the computational cost, which I have just talked of. It may escalate prohibitively, and sometimes the parameterization may not be adequate. So these handicaps, of the mechanistic approach can be overcome by synergically joining the mechanistic approach with the AI models. But of course, this can be implemented only if we have the necessary database. So our current data monitoring systems are oriented towards the mechanistic approach. So the monitoring programs have to be reoriented to cater to the requirements of the AI intervention. So this kind of change in our field work, the field strategies could over the time help us in synergically merging AI technology into the classical mechanistic approach. Yeah, thank you. So with this, I come to the end of my talk. I'm thankful to you for the organizers to give me an opportunity and to the audience for their time. Thank you.
Thank you, Professor Kashyap. I think it was a great talk to understand how you have used AI, or in particular artificial neural networks, on in the area of groundwater development and monitoring.
Yeah.
Thank you, sir. Thanks a lot for
Thank you.
talk.
Right.
And
I'll be happy to answer any questions at whatever stage. Yeah.
Sure. So with this, we come to the end of the technical sessions, and we have an open discussion session which will be moderated by Professor Pawan and myself. So Professor Pawan, it's all yours now.
Thank you, Dr. Rohit. I think we had very interesting talks from India as well as Taiwan, and in two different areas. This is the first time that we are having such a broad investigation into the two big areas. Actually, hydraulic engineering has a very long history of simulation and all kinds of models. And we do have some questions here in the chat box, but I think Dr. Dal has already responded to some of the questions. I'm not sure if Dr. Dal would like to add anything to the questions that were posed in the chat box.
Well, so there was an interesting question of how we can use artificial intelligence for the differently abled. So, users who could have some physical challenge, or even let's say any disability at mental level. So yes, there is a considerable amount of work which is being done, particularly to aid users in not only navigating. Let's say if someone has any type of visual impairment, that is difficulty in seeing the world in normal ways, then using object detectors and path planners, that's one opportunity. Another work is in with mental health as well. So we can actually use the facial expressions, the speech pattern to detect the mental state, the different facets of mental state, which can then be used for, let's say, well-being, improving the well-being, and even for the regular check of the patient. So there are endless opportunities right now with AI, especially for helping people with any type of disability. The only caution I would add to this is that we have to make sure that whatever data is being used and collected for learning these AI systems keeps into consideration the ethical and the privacy concerns. Yep. Thank you.
Thank you, Dr. Dal. There's one more question on AI reinforcement. I'm not sure if Dr. Dal or Dr. Chu would like to add to that. Reinforcement learning.
Okay, so I can, yeah. So what is the question?
He's asking that what exactly is AI reinforcement?
So, okay, so reinforcement learning is essentially we having a reward and a penalty function. So the easiest way to understand this is, let's say I have a robo arm, and the robo arm is supposed to pick up one object from a location and keep it in another location. Okay, so if it keeps it in the another wrong location by, let's say, having noise in the robo's motor, or even detecting where it should keep it, then there would be a penalty. There are different algorithms like QWave, and otherwise we would like to actually have some type of rewarding mechanism, that if, let's say, we are able to partially traverse from one state to another, then how can we improve it? So that's essentially adding to the belief of the algorithm.
Thank you,
Dr. A simple way of looking at it.
Yeah, actually, adding to that, currently we have asynchronous advantage active critic models, A2C and A3C, which are very advanced models and which have been used for playing games as complex as the Doom games and the other games.
Yes.
And that has been helping a lot to enhance what AI models can do. Dr. Chu, would you like to add anything to that, or if not, I would like to ask one question myself regarding self-distillation that you just mentioned in your talk. I mean, is it possible to use self-distillation in other classification? I mean, problems like, for example, for coffee beans or other things.
Yeah, I think so. Yeah, I think the self-distillation is just a strategy. Basically, you can. It's kind of somehow we will say that it's not really that the so-called knowledge distillation, because we actually don't need the teacher model. So we just start one model, and we want to improve this model iteratively. So basically, it's a strategy. I think if you are available, you can afford more power consumption or more computational resource. You can start from a relatively more complex model first, and then you try to improve itself iteratively. So I think it's a general strategy, not only for Mango images. It can be used in other applications, of course.
Thank you, Dr. Chu. Dr. Rohit, would you like to ask anyone in the?
Yeah, I have a question. After Dr. Rohit, I'll ask.
No, please go ahead.
Yeah, please go ahead.
So, Dr. Chu, I was wondering, so if we have a self-distillation model, will it be correct to say that the initialization of a self-distillation network learning is like self-supervised learning?
Oh, okay. So your question, I guess, is what is the difference between the self-supervised learning and the self-distillation, right?
Right. Or another way to say, is the initialization of a self-distillation similar to finding a pretext task in a self-supervised learning technique?
Yeah, I think the boundary between self-supervised or self-distillation is blurred. Okay, so I think I also see some self-supervised method that usually use like a cycle consistency to learn by itself. Okay, so it transforms from domain A to domain B, and then retransform domain B from domain B to domain A, and to make the cycle consistency. I don't have much opinion on this, but I guess it may be a quite interesting track track, research track currently. Yeah.
Thank you. Thank you. So maybe we can take some more questions from the hydraulics side, Professor Eric.
I'm sorry, Professor Lee has already gone offline, but he has left all the materials. So if anyone is interested in the simulation of wave hydrodynamics on ocean structures, he is very willing to discuss and share his materials with all the audience. I have one question for Dr. Kashyap, Deepak Kashyap, regarding the ANN models that you have used to to estimate the D and Q outputs that you just mentioned. I know that because of the reduction in, or not the reduction, the non, not following the restrictions of the physics and the other laws of nature. Normally, what happens is the ANN becomes a black box. And it is very difficult to explain what exactly AN is doing. Of course, explainable AI is being investigated, but it's still at a very immature stage. As you have mentioned, you have already compared ANN model with other more rule-following models. What exactly do you think that ANN has? Does it have any advantage besides the low cost of computation?
Yeah, it has several advantages, especially if we look at the input requirement of a traditional simulation model. There, apart from the forcing function, as I showed, one has to provide initial conditions, boundary conditions, aquifer parameters, which have to be determined from very expensive pumping tests, right? All those additional inputs are required apart from the forcing function. Whereas the ANN model now just receives the forcing function and produces the output without that array of additional inputs. So this, I think, if I can take you from a Hindi song, data sab janta hai, data knows everything. That means all those initial conditions, boundary conditions, aquifer parameters, all of them are imbibed in the weights which would be subsequently trained or which would be arrived at during the training of ANN model. So we may like to think that weights represent everything. All the conditions which we try to input into the traditional simulation model through hard numbers and through very painstaking field work, that could all be clubbed up in the weight array. So so this is my perception, because I'm a very traditional mechanistic modeler. Initially I was very skeptic about ANN, and especially in groundwater, because we always like to think we have good physics, good equations, and there's no need to go for all relatively what we considered as peripheral kind of modeling. But then, when I took up a very major project of this Yamuna Hindon Basin, and when I tried linking it to an optimizer, the computer time became an issue. It ended up requiring months of computer time. So then that is the time when I started exploring into the possibility of ANN model. So it has, because all those additional things are imbibed in the weights. But there is one catch here. Right now, as I said, see, our data monitoring programs are all oriented towards mechanistic approach, mechanistic models. So the data which are required, for example, here the data requirement would be in the context of illustration which I presented, corresponding to different crop areas which were raised over the years in past, historically. What were the lateral recharge to values to river, or what depths to water table were prevailing when those crop areas were implemented. Now, unfortunately, those kind of data are not being monitored. They are not available. So that is why we had to model those data numerically. That means this is a, maybe I'm not sure whether this is a common approach in the regular AI domain. That means we do numerical modeling, generate the data, and use those data for training the ANN models, and then use those ANN models for then we link those ANN models to optimizers to arrive at the optimal policy. So yes, ANN I can see have many advantages, but again, if I may just extend a little bit, see, we generated the data through numerical modeling. Now, as I mentioned, each run on the numerical model is expensive. So we could not generate maybe the necessary number of data. Maybe our database for the generation of ANN models was not adequate. And that is probably why we found the difference. You know, in the near optimal solution based purely upon ANN, the depth to water table was 20. But when checked on the simulation model, it turned out to be 23 meters. So that I think was because of the inadequacy of the database, again due to the the computational requirements. Okay.
Yeah, thank you, Dr. Deepak. Actually, we do that. We do a lot of data synthesis in a lot of different AI applications, especially applications that need to be applied to industry. We often have a lack of data, and data is often synthesized because without enough data, AI models cannot be trained properly. So we do need a lot of data, but the problem happens that the synthesized data are not actual real data. So so we are actually imbibing different patterns or artificial patterns into the data. So that makes the training, I mean, not so accurate. Yeah.
Yeah, just one more point. One more point. The advantage of ANN modeling in this context. See, because of this time crunch, the computer time crunch, many a time we compromise. We make many compromises in the traditional mechanistic approach. For example, we consider the cost of pumping to be independent of the depth to water table, whereas we know that as the lift increases, the cost of pumping would increase. But now when we go for ANN modeling, we can incorporate the lift-dependent cost of pumping in the objective function while computing the net benefit. So this means our planning can get more realistic as we synergically, link these two approaches. Yeah.
And just to add to this training of ANNs, I would like to narrate an example where what we are trying to do is apply it in a real chip environment, where you have a lot of data coming in and that contributes to signal integrity. The problem is that if you were to generate this data, you would require very, very time and computationally intensive field simulations using some commercially available FEM solvers that would run into several days to get a certain grasp of meaningful data. And that is where I think accelerated neural networks is another approach that people have been at least using it from an electrical and system design perspective. So yeah, that's something I would like to add here. Do we have some more questions, Professor Eric?
I don't have. Dr. Wong has, he's raising his hand.
Yeah, please.
Sorry, I have one question. As we know that the turbulent flow is very the compressible and unsteady even until now. Oh yeah, we can see that many turbulence modeling was built up. It means the flow mechanism is well until now. So I want to point out the question: how about if we try to use the AI and try to connect to use the in finding the wave flow, the turbulent flow. Do you agree with this question? Yes. Yeah. So
wave flow. I'm sorry because Professor Lee is not online now. He has already left.
Maybe the Deepak can be answered. the comment.
Could you right? Again here. This hydrodynamics, we have very well established, robust differential equations of hydrodynamics, which can be solved numerically to simulate the waves. But again, I think the computationally they are very, very demanding and intensive. And I would like to think the same concept could be invoked there too. That means instead of going for what we call as hard modeling based upon numerical simulations, we could generate data set either through field observations or through numerical modeling, synthesizing the data and generate ANN models. So what I feel in hydraulics, see in hydraulics, all hydraulics is derived from fluid mechanics, which is a very hard science. And then water resources is actually is kind of applied hydraulics, application of hydraulics for addressing the water resource, for addressing real life problems. So the science is relatively well known, I would say. So it is not the, see, the system, see, while modeling a system, the first thing before one can start modeling a system is to know the system well enough. So our systems are fairly well known, and so we can model them numerically. But mostly now the questions which come in are related to the computational cost. And that too, we have to keep in mind, we are not talking of high-end design or planning offices. There, of course, they may resort to cloud computing, and this may cease to be an issue. But we are talking of baseline field offices where the computational facilities may be relatively limited. So there, I think these neural network models, which mimic the real numerical models, they could come handy, and especially when they are linked to optimizers, because optimizers, they keep calling them again and again, and so the querying, the multiple querying is there. So that would probably hold there too, even in hydrodynamics.
Yeah, thank you. Thank you for your
Thank
take.
you. Thank you.
Oh, Professor Eric, you are muted.
Okay, thank you, Dr. Deepak, for the very
Thank you,
very interesting insight. Yeah. So, Dr. Rohit, do we move on to the closing of the session? I think it's already past our time.
Yeah. I think there is one question that I can just see, with your permission. I can just read it out. It is a young mechanical engineer who's from Anna University in Chennai, and he is asking if there are internship opportunities in hydraulics in Taiwan. I think, Professor Eric, you are the best person to answer it.
Hydraulics, I'll have to ask with Professor Lee, but we do have lots of internship opportunities in Taiwan now, especially because of the pandemic. All the internships were, stalled off for this year, but they are all extended for the next year, 2021. So if any student online or other students from IIT Ropar or other universities, they are interested in coming to Taiwan for short-term internships like 2 months to 6 months at most. They are all, funded by the Ministry of Education. It's called the TEEP program, Taiwan Education Elite Program, TEEP. So you can Google it. I think we do have lots of internship opportunities in Taiwan.
Yeah, and we also have similar opportunities in IIT Ropar. I think water resources and hydraulics is one of the key thrust areas of the civil engineering department of Ropar. Therefore, I think maybe Professor Kashyap can speak a bit about it, if there can be internship opportunities for students both from India as well as Taiwan.
Yeah, sure, there would be, because we have a strong faculty group in the area of hydraulics, water resources. So we would be very happy to receive applications for internship at all levels, undergraduate, graduate, as well as doctoral.
Yep.
And we also have PDS, postdoc positions, yes.
Right. Thank you, sir. Maybe I see Professor Martha. I think you have a. Do you have a question, Professor Martha?
Yeah, just I look. I already wrote once, I think, to the group of Professor Lee. So maybe I look again about more towards the application point of view, as he's doing now simulation. and I am also doing the theoretical part, but I will also look towards the simulation. So I am looking whether any exchange program can be made, like for a joint guiding PhD.
So if I can take this question, I think we already have a joint PhD program between CCU and IIT Ropar. It has already been approved at all levels, both the universities. We not officially started it for a simple reason, and that is the pandemic. Taiwan is not allowing visitors right now, if I'm not mistaken, and we are also very restrictive in allowing visitors to India. But you are right, we can start the process of identifying the guide, identifying the problem, and maybe in 6 months or 1 year down the road, students can actually travel to respective countries. So Professor Martha will get back to you.
Sure.
But to answer your question, yes, it has been duly approved in our Senate and BOG, and also in the highest academic bodies of CCU.
Okay.
Thank you.
Okay, fine. Nice. I think nice program. It was helpful, I think, to not only to me, I think many other people, audiences who are there in this talk. Thank you.
Thank you, Dr. Mata.
Thank you, Dr. Mata. I think, Professor Eric, we can move to the last section.
Yeah, sure. Yeah, so let's hand over the stage to Dr. Wang and Dr. Huang. Yeah, please.
Yeah, thank you everybody to join this wonderful today's join seminar. So before ending this seminar, I should also thank the Taiwan India Joint Research Center on AI, hosted on the National Chung University and the IIT Ropar. Yes, and I think this is a good start on trying to integrate different fields like the AI and the hydraulic engineering combined together to fine-tune some new finding and the new technology. I think it's very the good start, and I think as standing in my side, I will try my best to support all of the good communication and the good win-win between the Taiwan and the India in the future. So yeah, thanks again everybody to join this wonderful join the seminar, and appreciate the Dr. Huang and the Rofi and the show. Thanks again. Okay.
Dr. Huang?
Right, thank you all. You make this very professional webinars in the internet, and I learned a lot. I remember when I was in UK in 1994, and I joined one of project called MOS with Esprit project in Europe. That's joined with the Padova University. The MOS project is take care for the Venice tank. And last time we used MOS study in the simulation model. But to now I can see the MOS project sometimes work, sometimes not. Venice is still floating. So Deepak, your idea joining the AN with simulation model, I think that should be the right way to go through to make sort out all these dynamic problems. I learned a lot. I thank you all of you to give me a lot of new knowledge, like our AI joint centers. We are starting, and Rohit and IT Robot, they have the Indian, some of the opening ceremonies, and they talk about a new center is a new knowledge bank, and open all the people to join the center, have eyes and increase knowledge. And today I really learned a lot. Thank you all of you. Good luck. Bye.
Thank you, Professor.
Thank you, Dr. Rohit. Thank you, Dr. Deepak Kashyap, and all the
Thank you.
I think Director wants to say something.
Dr. Shivati, are you here? So do you give me the final comment before today's ending? Dr. Shivati, are you still here?
Yeah, I am there.
Yeah, please give me the final conclusion.
Okay. Thank you again for giving me this opportunity. So it was really a very wonderful event and very enriching presentations from all the participants, and the themes ranging from agriculture to business and then hydraulics and oceans. It's a very broad areas, and then it's really very enriching participation today. And also, I am also glad to see the very good industry participation from India, like TCS and Tech Mahindra. So what we need to do is both academics and industry partners should work together. We need to very aggressively assess what the industry needs, and depending upon the requirement of the industry, we all academic people.
I think there seems to be a network issue at his end.
Dr. Shivaji? Yeah, we cannot hear you. Dr. Wong?
But I think we understood the point that he was trying to make, that we should reach out through industries and try to connect more people both at CCU and IIT Ropar for the longevity and sustainability of the center in the years to come.
Yeah. So, Mr. Ashwin Prasad, are you online? Tech Mahindra? No.
Yes.
Would you like to say a few words at the end?
Yeah, of course, absolutely. Like, first of all, thank you. I think this is an amazing forum where corporate like Tech Mahindra get an opportunity to share the perspective. And I strongly believe that, like I said in the presentation as well, that we are actually looking for ecosystem of partners like industry and academia, so that both, because industry have a particular solution and technology and infrastructure, academia definitely have people, skill set and human resources. So we should definitely leverage our strength and work together. And Tech Mahindra is always open for such partnerships, both from India and Taiwan side. And I'm very excited, and this session was absolutely very useful. I really loved the way we discussed in length and detail, and looking forward for more collaborations like this ahead. And thank you.
Thank you, Ashwin. Thank you, Ashwin. I think actually we can, in the future, we can actually discuss how Tech Mahindra can cooperate with our India-Taiwan Joint Research Center. Yeah,
absolutely.
Okay. Dr. Shivanti is raising his hand.
Yeah. In between, I lost the connection. I'm sorry for that. And I just, as a last word, I would like to say that for all the Indian participants, in DST, we have very exciting program on interdisciplinary cyber security, physical systems. So this very good program as far as artificial intelligence is concerned, and it has very widely circulated, and large number of participants are already coming. And to mention, our youngest IIT Ropar has already received very wonderful funding for technology innovation hub on agriculture and water. So this very important program, and maybe our Indian colleagues can, in particular, the Indo-Taiwan cooperation, there are plenty of opportunities. What we need to do is we need to explore further and try to go hand in hand with IITs and universities at the background, and DST and other funding agencies are at the background. Thank you, and all the best success for this event.
Okay. Thank you. Thank you.
Thank you, Dr. Shivaji, the good echo. Thank you.
Yeah. So do we end the whole seminar? Thank you so much.
Thank you.
Bye-bye.
Thank you.
Okay, thank you. Thank you.
Bye-bye.
Bye-bye. Bye-bye. Bye-bye.
Thank you, Professor.
Thank you. Bye.
Bye.